Just a second. Yeah, is my screen visible?
Yes, yes.
Yes, thank you. Professor Dr. A.S. Sahi, sir, I'm going to read his brief profile. Dr. Amandeep Singh Sahi, sir, is currently working as a professor at head Department of Mechanical Engineering at Sant Longowal Institute of Engineering and Technology, Longowal. He did his PhD in Mechanical Engineering from Indian Institute of Technology, Delhi. His research interest mainly focuses on the engineering alloys and include welding, metallurgy, corrosion, fatigue, alloy development, additive manufacturing, and material modification. He has supervised 7 PhD besides several MTech and BTech projects. He is also actively involved in consultancy works, especially related to welding and fabrication industry. He is a reviewer of several international journals. He has visited USA, Canada, Sweden for disseminating his research work in the various international conferences. So it's my great pleasure to welcome our guest of speaker of this session, Dr. Amandeep Sahi sir. I would like to request the Sahi sir to please share your screen and guide us.
Thank you, Dr. Praveen. Thank you very much. Just let me. Is my screen visible, Praveen?
No, sir, not now.
Just a second. I need to go to this. Just 1 second.
There is a green button there.
Yes.
Yeah, it is coming, sir. Yeah, it's visible, sir. Perfect. So please make it in a large screen. Sir, your time is from 12 to 12:40.
Okay, fine. Thank you. Thank you, Dr. Praveen. Dear participants and attendees of this session, a very good afternoon to all of you. First of all, I'm sorry to be late by around 5-6 minutes due to some compulsion at my end. So as far as today's talk is concerned, the title that I have chosen to deliver is Material Characterization of Engineering Materials Used for Critical Applications. Now the need and importance and the relevance of this topic, let me clarify it. So these days, we mechanical engineers, we are undergoing a transformation in terms of the advent of new materials, because of the reason that the service conditions have become so harsh in the actual environment. If you talk about the mechanical loading of the components, which involve critical properties like fatigue, then you talk about some marine applications, corrosive environments are involved. So likewise, there is a constant pressure on the mechanical engineers, not only to design the new products, new fabrications, but at the same time, act in the role of a material specialist so as to come out with the materials that could possibly be in line with what is being demanded from the extreme service conditions. So today's takeaway, what I expect from today's lecture is that I will be taking you through a series of slides where number of material characterization techniques have been used in order to gain insights into the behavior or the character of the material so as to result into generation of a database that could be used as a priori information for various applications. Because obviously, when you have to design, you have to develop, you have to fabricate, you have to make a structure out of it. Obviously, what we expect is it should be able to live up to its designated life without undergoing premature failures. Dr. Praveen, just audio video is okay?
Yeah, sir, it's perfect.
Okay, thank you. Let's move on. So some of the contents that I would be covering today are optical microscopy, although it is very general, but still I'll give you a glimpse of what we are doing here. Then corrosion evaluation via electrochemical methods. Then the role of scanning electron microscopy as well as fractography. Then EPMA electron probe microanalyzer with wavelength dispersive spectroscopy, optical profilometry, XPS for passive films. Now you don't need to worry about the abbreviations given here. Just try to get into things how these techniques are important and what sort of insights would be gained into studying the behavior of any material which is meant for critical applications. I'll come to this also. Then what is meant by the term critical applications? Now, when we talk about few applications of stainless steel, this is one category of stainless steels. This is austenitic stainless steel grade 300 series, AISI 304L as well as 316L. Now, major chunk of these stainless steels, around 70% of the applications, they involve these type of grades of stainless steels. And there are few stabilized steel also which contain titanium as well as niobium. So AISI 321347, like, in order to impart better corrosion resistance to such materials. So when we look at the applications part, petrochemical plants, chemical industry, nuclear industry, shipbuilding industry, boiler and pressure vessels, manufacturing units, aerospace applications, pipelines, dairy industries, fertilizer, etc. All these are critical applications which involve that the materials that have been used to fabricate those structures should be able to undergo their designated life without premature failures. Now, when we look at another category of steels, it is duplex stainless steel. This list also contains few important applications like pressure piping systems, pressure vessels, storage tanks, structural components, blast and fire walls. Let me remind you of these bridges. Nowadays, there are certain countries which are using duplex stainless steels entirely for making bridges out of this important engineering alloy, cargo tanks, evaporators, heat exchangers, suction roll shells, rotors, impellers and shafts, vehicle and chassis components. So these are some of the applications which involve duplex stainless steel. Now this is one. Now here we have this chromium and nickel content, which means when you look at it as a alloy designer, there is a certain proportion of alloying components that is mandatory to be included in any design of an alloy so as to make it possess certain minimum characteristics. For example, if you have chromium of the order of more than 18%, nickel more than 8%, it becomes a category of stainless steels. So here, this is how different categories, they have been shown in the shaded region. If you look at it, this is the major chunk of austenitic stainless steels. So this is the, you can say, the most important member of the stainless steels family. This is the workhorse of stainless steel, basically. Now, I will not be going through all the details of this. This is just a one case study which helps us in demarcating a normal application and a critical application. Let me remind you of this incident which occurred in one of the nuclear power plants in Japan. Fukushima disaster was there. There was a case of nuclear leak which occurred due to the reason that tsunami was there. Due to that, what happened, there were 4 reactors, right? So which met the damage due to this accident. So the 3 cores which were there on the nuclear power plant, they largely melted in the first 3 days. So the implication was, obviously, when there would be melting, there would be the possibility of leakage. So leakage in such units, it can be very disastrous. Let me recall you of the tragedy of Bhopal gas tragedy, if you recall, right? But things have much changed now. But unfortunately, such incidents, they continue to occur with a very disturbing frequency. So if you see, evacuations have to be carried out, right? If you look at the Japanese nuclear power plants, so this is what it looks like. So this is basically the cross-sectional view of how does it look alike, right? So this is your reactor pressure vessel. And just keep one thing in mind, look at the material constraints. The materials, they have to be very, you can say, they become so demanding due to the service applications. Lot of ionic bombardment activity is there. Continuous exposure at high temperatures to these materials can lead to bring in drastic changes in their mechanical as well as metallurgical behavior, right? So here, so what happened? Obviously, a lot of investigations, they went into these. So even NASA also participated in this process, and they came out with an idea that yes, the leakage occurred due to the reason that the material was not able to sustain that high temperature application. So what they suggested was that to go for adding zirconium to the already existing component, whereby that component would be able to sustain a temperature of around 1700 degrees centigrade. Now, the occurrence of this incident, that is a tsunami, was not expected by the Japanese engineers, although they usually take into consideration the seismic waves and all that, lot of activities relating to fatigue, etc. But this thing was not taken in a manner that tsunami would give rise to a high tide of around 10 meters high, which will submerge the entire plant. Right? So, which means, now let me take you to this thing. If we look at it, if we are able to have a material which would be able to sustain better temperature, you can say conditions than this, obviously such tragedies would be avoided, they would be prevented. So that is the kind of challenge that we mechanical engineers should always be triggered with in our subconscious mind, that yes, we have to go for the best quality materials, we have to go for high performance material, we have to take care of the materials that should be able to perform in a better way for the purpose for which they have been designed and fabricated and put into actual service environment. Just one small discussion on this, the Titanic disaster. All of you know that the unsinkable ship made by the best brains of British engineers. They had this ship, right? It was a very challenging, you can say, fabrication work, but the claim that at that point of time was worldwide that yes, this ship will not sink in any case, right? But unfortunately, we know the history, it sank, right? Due to the reason that the material was not able to sustain the that tragedy. It hit with an iceberg. The rivets were made from the steel, which was inferior in quality and hence was not able to perform up to the mark, right? Temperature was sub-zero, right? So impact toughness going down drastically on the lower side when the temperature conditions are sub-zero. We all know that obviously Charpy V naught or say impact toughness goes down in such materials, right? So lot many investigations again went into this disaster. Just look at this. The concerning issue was, now this was these are the results of the modern steel. If we compare the steel that is available today for shipbuilding, this is how it looks like when tested after conducting CVN test, that is Charpy V noise test. But when that frisbee size disc was taken from the sea floor and the tests were conducted, failure investigations were carried out. So this is what the results were obtained. So what you see here is, on this side, what you're able to see is, it depicts a ductile material, whereas the ship that was used for making of Titanic, it exhibited a very or extremely brittle behavior. So obviously when such a steel would hit with an iceberg, with an impact, and the temperatures are sub-zero, obviously the result would be a brittle fracture. So that's why it took very little time that the ship could not sustain or could not float, remained afloat on the sea. So these are some of the concerning issues, right? So similarly, when we look at few failures that are related to austenitic stainless steels, so this is a small list of those failures. Failures could occur due to sensitization. Obviously, such steels are they are rather designed and fabricated to sustain high temperature corrosion applications. Pitting corrosion failures, another form of pitting. Thermal fatigue failures, when the temperatures, there is a range of temperatures, high, low, high, low. Hydrogen embrittlement is there, oxidation is there, stress corrosion cracking is there, corrosion fatigue is there. That means corrosion is also there, as well as the structures, they have to sustain fatigue loading conditions also. So these are some of the failures that have been recorded and investigated for these steels. Okay, I'll be skipping few of these slides, this small glimpse of when we talk about the microstructure of austenitic stainless steels. We know that in case of austenitic stainless steels, ferrite is dispersed in the austenite matrix, and this is how different morphologies of ferrite are visible. Fully austenitic, there is no ferrite. It leads to the problem of solidification cracking, eutectic, vermicular, lithiferrite, Widman-stated ferrite. So this is how black indicates ferrite content and white indicates austenite. Okay, now when these materials they are welded, sometimes they have a tendency to undergo the problem of solidification cracking. If you just look at it, this is the type F solidification where cracking has occurred. In these cases, no cracking is observed, so indicating the importance of obtaining such solidification patterns which will make these steels resistant to solidification cracking. Next important is the concept of this sensitization, or also sometimes known as carbide precipitation, also sometimes referred to as IGC, that is intergranular corrosion. So these are the two schematics showing that when austenitic stainless steel, it is subjected to corrosive environment, high temperature, what happens is there is a depletion of chromium from the austenite near grain boundaries. Just look at it. Now this is the grain boundary. In the immediate vicinity of this grain boundary, what happens is chromium has a tendency to combine with carbon so as to form chromium carbide, Cr23C6. These dark spots indicate the formation of chromium carbide. And as a result, what happens is the region in the immediate vicinity of this carbide, this grain boundary, it becomes depleted in chromium and hence would result into the formation of, say, drastic loss of corrosion performance because of the precipitation of carbides. Now what I do is I take the cross section from this grain boundary, and what I'm able to see is this one. So here what happens is, what I see is, this is the central portion, that is, now in the immediate vicinity what is happening, the chromium content has gone down to below than 18%, and here it becomes 12%. So obviously when there is a formation of such carbides in and around the vicinity of this grain boundary, so these areas, they become vulnerable to corrosion attack. Obviously, any stainless steel is referred to as stainless steel as far as this grade is concerned. As long as your chromium is more than 18%, it will behave as stainless steel. But if it becomes lower than that, it will become vulnerable to corrosion, like in this case. Now here, these are the time temperature sensation curves, how time and temperature affects, right? So higher the temperature, lesser would be the time required to induce sensitization or promote the formation of carbides. So like here, it's not only Cr23C6, it could be formation of further carbides of chromium also, Cr3C7, C7C6 also, right? Okay, here, so I'm talking, now there's quite a lot of text is here, I won't be covering this, but yes, when you have to go for the evaluation of corrosion of such steels, what you have to do is you have to take out the specimen of this material, then you have to use this practice ASTM A262 practice A oxalic acid test. That is, it is tested for its microstructure, and these are some of the optical microscopy tools. This is the Technology-Zoom microscope. We have to take the macro image of any specimen. It is captured on the screen with the help of a CCTV camera. It is coupled to this. Software facilitates the acquisition of the data from here. This is the inverted metallurgical microscope, which helps in capturing of the microstructure of the given specimen. So this is how the captured microstructures would look alike. So here, if you just look at it, I have taken these three different microstructures. These are the actual microstructures of AISI 316 cell grade of steels, which have been welded using three different levels of heat input: low welding heat input, medium heat input, and high heat input. So here what we can see is, the note for the observation is, as you go on changing the heat input to this material, it responds in a manner that there would be change in the delta ferrite morphology, right? So which can have important implications on the service performance of this particular fabrication. So just look at it. So here, low, medium, high heat input. These specimens, they were subjected to low temperature sensitization as well as high temperature sensitization. So that means there was a deliberate attempt to induce, nucleate the chromium carbides as well as allow them to grow to their say designated point, so as to have characterizing the performance of such materials that would be able to perform adversely. What we expect is when such carbides they are formed, how they are going to behave. So this is a matter of investigation. This is what we want to do here. Now coming to one more crucial point is, just look at the heat affected zone. Low heat input. This is, here the joint was subjected to 550 degrees centigrade for 11 days continuously. Here it was subjected to 750 degrees centigrade only for 2 hours. Medium heat input joint with the same treatments, high heat input joint with the same heat treatments. Now, if you want to select as a fabrication specialist, you want to extract one, you want to establish one welding procedure that would obviously not be the one that would lead to higher precipitation or high sensitization of this material. At the same time, what we are able to see here is, look at it, one more phenomenon is observed here. This is the heat affected zone, this is the fusion boundary, this is the weld metal. So this results into the heat affected zone grain coarsening. So this again has adverse implications. If you just look at it, grain size, compare this, it enlarges in this case, it further enlarges in this case. So that means obviously if the heat affected zone is of varying size, the performance of the joint again is going to be of different nature. The consistent performance will not be obtained from these. So this leads to one important point, that while fabricating, due consideration should be given to selection of a suitable combination of the parameters so as to result into the optimal microstructures that will be able to result into better mechanical properties. Because we know fundamentally, obviously, there is a definite relationship between the microstructure and the mechanical properties. So I would be skipping this. Obviously, once there is change in the microstructural morphology, obviously, micro hardness would also change proportionately. Okay, looking at the impact toughness results, earlier what was discussed, if you look at this, I'll just take one over here, low heat input. So what we observe is, as we go on aging these specimens, there is a drastic reduction in the impact toughness properties of the weld metal, and more drastic reduction is in case of the heat affected zone toughness. Look at this, 230 falling to somewhat below 200, then 130 falling to somewhat below 60. Since HZ is an integral part of the weld metal, and as a whole they have to serve in the actual service application, so obviously this becomes a serious issue for mechanical engineers. Now here, if you look at it, so when we look at the fracture morphology of these specimens, for example, we take the CVN tested specimens, fractured ends, they were viewed under the microscope, that is scanning electron microscope. This is how the things look alike. How do we interpret? First of all, what is contained in this slide? There is a dimpled morphology indicating that yes, nothing has gone wrong as far as the ductility of the material is concerned, right? But yes, when we look at the heat affected zone, there is some drastic change involved here. There are cracks which are visible over here. Look at these cracks also, right? Bright face heads, then flat featureless regions where you can say dimpled morphology is not observed. So it is a warning sign that yes, the material has undergone you can say undergone a drastic reduction in its ductility. So that becomes a worrisome issue. Let me tell you, if you recall our previous example on the Titanic disaster, the issue was related to the ductility. Obviously, when the material is not ductile enough, it doesn't hold any capacity to absorb the plastic energy. Obviously, it would yield at a very low stress level. So this is exactly what had happened on that day, on the unfaithful night of that the Titanic disaster in 1912, when the ship hull it struck with the iceberg, the rivets they came out very quickly because they yielded in the process since they did not exhibit sufficient ductility. So extreme brittle nature was it was mainly responsible for that, the occurrence of that tragedy. So now, when we look at the heat affected zone, the situation becomes all the more serious. Just look at it. When I say, one thing is quite clear here, when we look at it, there is loss of dimpled morphology in these fractographs. Look at it, that the signs have started appearing in the fractograph that there is some loss of dimpled morphology regions. In this case, dimpled morphology is minimal now, which has now has been taken over by these intergranular cracks. These are the continuous cracks which occur along the grain boundary, and hence the name to be called it as IGC, intergranular cracking. If the cracking occurs along the grain boundaries, it is referred to as intergranular cracking. But if cut across the grain boundaries, it is called as intra or transgranular cracking. So same is the case here. Now, interestingly, as we talked about the previous example where the heat affected zone, it showed a drastic reduction in its ductility or impact toughness. Look at this, that the ductility of the grain boundaries has gone down to an extent where an effect called grain boundary separation has occurred. So which means that the grain boundaries had weakened to an extent where they could not hold together with each other, and the end result is what? Premature failures. So that means such fabrications will not be able to live up to the designated life for which they have been designed and developed to serve a particular service environment, which at times could be very or extremely harsh, right? So we are talking here about the industrial grade 316L grade alone. Okay, then another view of optical microscopy. So here it is just a glimpse of, this is the niobium based, this is how the differentiation is made. Niobium is contained in this felt. So there is a difference in the morphology of the conventional 316L and the stabilized this grade. Now, I'll take you a quick look through how the corrosion evaluation takes place. We go for electrochemical techniques in order to find out the corrosion behavior of such materials. So as we discussed earlier, we talked about the impact toughness evaluation. Impact toughness is basically a bulk property, whereas corrosion is a surface property. So this point of discussion is going to let you know about what methods are prevalent in evaluating the materials for their corrosion performance. So this particular method is known as DLEPR. Right? If you see here, this is double loop electrochemical potentiokinetic reactivation method. So this is an electrochemical cell. This is the workpiece under consideration. Surfaces are exposed to the electrolyte. This is the counter electrode made up of graphite. This is the reference electrode, which is called as the saturated caramel electrode. This is an instrument known as potentiostat, which controls the potential, that is voltage, and in return, what is measured is current. So this is how the circuitry goes like. So this is, there is a software called DC105. It will let you know the performance of this specimen when it is subjected to such type of corrosion evaluation technique. So this is what we get to know from this result. That is, just a second. Okay. Now here, if you look at it, this is how the curve goes like. We start from here, like this. This is the anodic scan. It goes like this, just follow this cursor. Then this is the point from which a reverse scan occurs. That is, this is the reverse scan which comes down like this. So there are two values that are to be obtained from this curve so as to result into one quantitative information, that is DOS. DOS basically stands for the term degree of sensitization. We just talked about, we evaluated, we checked quantitatively the impact absence of our specimens, the weld metal as well as the heat factor zone. But here now, what we intend to do is, we intend to find the degree of sensitization pertaining to these surfaces. So right now we are talking about the surface evaluation of these specimens for their corrosion performance. And this corrosion performance in particular is the degree of sensitization, that is the extent to which the carbides have formed inside the material. So what we do here is, IR1 is the reactivation current, IR stands for reactivation peak current density, IA stands for the activation peak density. The ratio of IR over IA is multiplied by 100 is what we are able to see in the form of DOS in percentage, right? So this particular slide contains specific research information, that is 316L in the as welded condition has degree of sensitization 13.67%. So that means while these joints were fabricated using a gas and arc welding process, all industrial standards were followed. But despite of that, what had happened was that the joint, it suffered from the carbide precipitates. So carbide precipitation occurred within the joint, even in the as welded conditions. Just think of a situation when that such a fabrication in the as welded condition is allowed to become part and parcel of the actual service application. So the results, they can be devastating at times. As long as the conditions are normal, there is no harm in using such fabrications. But look at the worst condition. If due to accumulation of, say, a temperature or corrosive environment becoming extremely harsh, it might again result into premature failures. So that becomes a worrisome issue for us. So when it is aged, that will, we deliberately, we add precipitation products into it. Look at its DOS. Degree of sensitization has increased drastically. It has gone to 60 point something percent. Then look at it. Here we talk about the stabilized steel. When I add niobium to my material and call it as the stabilized steel, niobium stabilized, DOS is only 2.37%. And if I subject it to a high temperature aging condition of 750 degrees centigrade for 24 hours, it becomes 14.88%. So what is the major takeaway from this particular result implication? That is, in this case, if the conditions are extremely harsh, do not use 316L, but rather go for 347, because in the as welded condition and even in the aged condition, the degree of sensitization associated with it is still lesser than that. Okay, now regarding the pitting corrosion. Hello.
Sir, sorry to interrupt you. We
No,
have
no
less than
problem.
5 minutes. 5 minutes, sir.
Oh, okay, I have to conclude within 5 minutes, or I should spare 2 minutes for any queries.
Yes, sir. You have to. You have a time for.
Then I am left with only 2 minutes. So I'll just quickly take you people through this. That what all I wanted to discuss. I will be skipping this. Certain mechanisms responsible for the occurrence of pitting. Right. So this is how the pits, they look alike. Look at the HZ that we talked about, HZ grain coarsening. Look at its implications as far as its pitting performance is concerned. So which means the HZ microstructure has become so vulnerable that it leads to the nucleation as well, growth of the nucleation, the growth of these pits. So these are the XRD results, that is X-ray. These are the pitting performance results. Then further, we can also characterize these pits for their composition as well as their exact geometry, their shape, their size, their roughness. Look at this, 29.9 micron size is the diameter. This is depth. Depth is 40 microns. Look at these surface roughness on the pits that has gone due to aging. Look at this. Similarly, another technique, electron core microanalyzer, giving us each and every composition at one single point of 1 micron size. So this is how the results are there. So we can also go for the XPS depth files. Just to know that the corrosion protection layer consists of what and what is its depth. It contains oxygen, iron, chromium, nickel, moly. Here niobium is there, right? So this is how. Okay, then this I will have to skip. Okay, what we conclude from our today's talk is we discussed about main characterization techniques, right? So where we saw that how the materials behavior could be studied using these standardized and well-established, well-proven techniques in the industry as well as the research, you can say organizations. And finally, we can conclude that material characterization is important for gaining important insights into materials behavior so as to assess or predict the service performance of engineering structures or fabrications with reasonable accuracy and reliability. So accuracy is important, reliability is important, because what we wish is that there shouldn't be any premature failures. Now, I'm open to any queries. If you have any query.
Thank you. Thank you very much, sir. We have some questions from the participants.
Okay.
The first question is it possible to maintain fine structure and ductile properties at same time?
Fine structure and yes. So it is kind of a trade-off between what sort of heat inputs are you are using to fabricate your joint, right? Because within a single process, there are multiple combinations which can help you in achieving sound weld quality. But within that, still there is a scope that if you come out, if you decide about an operating window, within that, you should try to look into the optimal use of heat input, which would preferably be on the lower side. Lower the heat input, finer would be the microstructure, and accordingly, proportionally, the properties would automatically follow. Distortion effects, residual stresses, they would be relatively on the lower side if you select combination of the parameters which are relatively leading to lower heat input energy combinations. Next question.
Okay. Sir, the next question is, what is the solution of DBT, ductile to brittle transformation? Is it only heat treatment process is the solution of DBT?
Pardon, please repeat.
What is the solution of DBT, ductile to brittle transformation?
Okay.
Is it only heat treatment process is the solution of DBT?
No, not at all. Let me tell you one thing very important from today's discussion also, you might have seen this thing. Time and again, I had been highlighting about the importance of the selection of the optimal combination of the heat input. So I'm not only talking about the, welded joints, but you could think of any processing route, be it a casting, be it a forging process, be it a rolling operation, how the pressure vessels are made, or be it welding, right? So each and every processing route will have to be checked out for arriving at the most optimal, you can say, combination of the parameters that would first result into the best properties in the as processed condition. That is the first point, right? Thereafter comes the role of the heat input, heat treatments or aging treatments, so as to extract the beneficial effects of the heat treatments and to get them induced into your fabrication so as to enhance its properties and hence service performance. Next.
Thank you, sir. Hope you are clear. Next, how to improve the impact properties of AISI 304 at very low temperature?
Okay, the very first thing is that you should have an adequate microstructure containing or say ensuring two things. One is percentage of delta Freight into that. The second important thing is to maintain the morphology related to that. So morphological features as well as Freight content, they are important in improving its impact toughness. And obviously there is a saturation limit. You cannot go beyond the maximum achievable impact toughness.
Okay, sir. Sir, one more question from our BTech students.
Yes.
Mr. Avinash Adarsh, that is, why does corrosion happen in stainless steel containing more than 0.08% carbon?
If you recall one of my slides, I mentioned about chromium has a tendency to combine with carbon so as to result into chromium carbides. if you are not able to suppress carbon. So that's why we had the need of going for L grades, ELC grade. 304 and 304L, they are different. L is used, which is extra low carbon grade, where carbon is less than 0.03%. So here the intention is to have carbon go down to a level where even if precipitation occurs, it should not be accelerated. But if your carbon is on the higher side, it is 0.08%. Obviously, it is an open invitation to the chromium to meet with it and hence result into this precipitation. So 304 normal will not be recommended for the extremely harsh corrosion conditions. So that is the demarcation between the normal grade and the extra low carbon grade. Please go ahead.
Thank you very much, sir. We have received lots of the question, but due to the shortage of the timing, I'm not taking all of the questions. Thank you very much, Dr. Amandeep Singh Sahi, sir. It's my great pleasure to see you again.
Thank you, Dr. Praveen. Thank you very much. And your organization, MIT University, for giving me this opportunity to interact with you people for the first time in my career. And I hope to carry forward this interaction with you people.
Sure, sir. Sure.
I love talking to you people. Okay, bye. And best wishes for the next part of the conference.
Thank you, sir. Thank you very much, sir. You may leave now, sir.
Sure.
Okay, thank you.
Yeah.
So, participants, as I have already shown to you that our first presentation is of Mr. Muhammad Amir. Muhammad Amir, are you there?
Yes, sir. I'm here, sir.
Okay, thank you. So before starting the presentation, I would like to invite our session chair, Dr. Ashwani Kumar, sir. Sir is working in SGT University as a professor in Department of Mechanical Engineering. Sir has around... Sorry, Amir, please close your mic. Yeah. Sir has around 4 years of experience in research, 7 years of teaching experience in different universities known as Vinoba Bhave University, Hazaribagh University, Vinoba Bhave Hazaribagh University, SPPU Pune, SGTU Gurugram, and also have almost 2 years of industrial experience in technical consultant. Additionally, sir has involved as a reviewer, member, editorial board member in some of the internationally acclaimed research journals such as Springer, Elsevier, Wiley, etc. So we, the MIT organization and the ICMMIT group would like to welcome Dr. Ashwani Kumar sir for joining us as a session chairperson. Now I would like to request Muhammad Amir, whose topic is polishing performance of magnetic nano composites based nano abrasive. Please share your screen. You have 10 minutes from now, 8 minutes for the presentation and 2 minutes for the question answer round. All the presenter who have any query, please put your question in question answer session section or the chat box. Yeah, Muhammad Amir, over to you. Muhammad Amir, you are muted. Please unmute yourself.
Hello, sir. Can you hear me?
Yes.
Is my slide visible to everyone?
Yeah. Yes. Please continue.
Okay. Thank you, sir. Thank you for. This is from Ramit. I'm from IIT Technique with PhD. Today I will present you on the polishing performance of magnetic and composite based nano abrasive. This is my contents. I will briefly introduce you about the topic and the research. What are the research challenges, and how can we develop the materials, and then structural analysis and polishing performance. And then I will give you a brief summary of the research. So there are optical components which is used for advanced instruments such as astronomical telescope, defense and equipment, and high power laser systems, extreme ultraviolet systems. So where we use optical component which have a very high surface accuracy of surface finishing. This surface finishing has been was done by the fabrication process. In a fabrication process, we use we have polishing abrasive, which is normally used to get the surface up to angstrom level. However, there are some challenges. These techniques are such as chemical mechanical polishing and MRF, magnetic rheological polishing. Here we have factor affecting the polishing performance of the optical components. So we have abrasive and the polishing pad. This polishing pad are made of polymers and other materials, and abrasives are made of often metal oxide and metal elements. The process are involved with the chemical mechanism as well as mechanical action, and these are the dependent factors such as mechanical strength, concentration, time, pH, particle size, work environment, and abrasive solvents and its concentration. They are commercial available abrasives are silicon oxide, alumina, zirconium for the glass and other materials. However, these abrasives have some limitation and there are some challenges. And these are, it has a reusability and sustainability lack, and it has a corrosion problem. It provides you a random removal rate, and achieving surface to angstrom level is quite difficult. It's very difficult, and the most important point is it doesn't have a recyclability and reusability in nature. So we have designed our material in a such way that which will give you all these features which we are looking for. So we have taken a spion. Spion is nothing but it's a super paramagnetic iron oxide nanoparticle, which is used as a magnetic coat here, and also as well as abrasives. And in order to protect it from the corrosion and to get a high surface area, we have coated the layer with the organic molecules such as malic acid, and we have developed this nanoabrasive in the using chemical method called hydrothermal route. And then organic layer was done in order to protect it from anti-corrosion, anti-agglomeration, and high surface area. And also it will provide you high homogeneous cutting effect. These are our structure analysis. Some characterizations are also done for the abrasives, and these are the extra XRD of the developed nanoabrasive, and it provide you a very cubic inverse structure of molecular surface. And also it is a FTIR which confirm the strong interaction between malic acid and the spion. And so also provide OH, which is useful for the chemical process during the chemical action of polishing. Also, these are the morphological analysis. We can see that the particles are agglomerated, and the particle are spherical in nature with a uniform size distributions. But this agglomeration can be resolved during the preparation of the slurry, and this slurry can be checked using the zeta potential. Particle size analysis was done using the TAMINH, and it is found that the particle size are 10 into 30 nanometers in size. Then we have done the bed analysis in order to understand the adsorption and desorption behavior of the developed abrasive and the surface area as well as the pore diameter. And it is found that the surface area is 54.39 millimeter square per gram, and also the pore size is very high, 16.48 nanometer. The adsorption desorption capacity is found to be very uniform and homogeneous. Then we have prepared the slurry using the water aqueous solvent, and we have done the zeta potential.
You have last 2 minutes to present your paper.
Okay, sir. We have the zeta potential of the zeta potential of the abrasive, and it has found a very strong stability. Then we have done the last application was done for polishing performance. We use BK7 optical disc of 50 mm diameter, and we have made a 5% of this slurry concentration. Then we use this, polishing performance at different pH such as pH 5, 7, and 12. We use a polyurethane pad as our polishing pad. we followed the two different models, such as contact layer model and indentation model. This model is defined as a when the particle size is smaller, when it's smaller, then the material removal is increases, and this is for the bigger particle. So we have to want to look at the see what which contact area they are, which areas model is following. We have done the polishing performance result at pH 5, and we found that the before polishing it was 240 nanometers surface roughness. Then after surface roughness was achieved to 0.54 nanometer, that is 5.4 angstrom. As the pH increases to 7, the surface roughness improved to 0.33 nanometer, and as the pH is become very high, then at 12 the surface roughness reached to the 2.3 nanometer, 2.3 angstrom. This which indicate that the particles are very developed abrasives, providing you super fine angstrom level surface. Then we have recovered the abrasive using the magnetic external magnet, and we perform the magnetic performance, which give you 66.65 EME per gram. And we in this method we have taken the abrasive we have from the polishing system, and we reuse it.
Mohammed Amir sir, please just stop with your presentation.
Yeah, conclude first.
Please conclude.
Yeah, this is the summary that we have successfully developed the SPL and abrasive, and then because of the regular spherical side and narrow size distribution, it will provide you a high homogeneous surface cutting effect, and then polishing performance was seen as a angstrom level surface finishing. Thank you, sir. Thank you.
Okay, thank you. Which is very nice presentation. May I request to our session chair, is there any question from your side, Dr. Ashwani sir?
Yeah, Dr. Mr. Amir, I think your name is Mohammed Amir.
Yes, sir. Yes, sir. Yes.
Okay, good morning and very nice
Thank you.
presentation from your side. And almost it was just less time, but it was just hard to understand all the things. But just give me a short brief in only 1 minute that what the research gap have you found in your research?
Sir, the commercial abrasives, which is used for polishing to polish the surface optical component, which is used for high instrument, advanced instrument, optical instruments. So there's a problem is surface roughness, reaching the surface roughness at angstrom level is quite difficult using the commercial abrasive. They have reached just to 1 nanometer, around 1 nanometer, 10 angstrom. But and also the commercially available abrasives are not in recyclable form, sustainable form. It has a corrosion problem. It is not recyclable in nature. It is not reusable in nature. So we have developed an abrasive, which is providing you up to 2.3 angstrom level surface finishing with recyclable and reusable in nature.
Okay, then. Okay. Thank you.
Okay, thank you, Mohammed Amir. You can leave the session or join or listen to other presentation.
Thank you, sir. Thank you.
Okay, next is Mr. Sukhjinder Singh. Are you available? Mr. Sukhjinder Singh.
Yes, Mr. Sukhjinder Singh. Sir, this is the last call for you.
I think Sukhjinder Singh is not in a co-host. Please join. Yeah, he is in co-host.
Yes,
Sukhjinder Singh, yeah, are you available?
Yes,
Please
sir. Yes, sir.
Please share your screen.
Yes.
The topic is a review on protection of boiler tube steels with thermal spray coating from hot corrosion. Your screen is not visible. Yeah, please.
Yes. Please continue, sir.
Your time starts now. It's 12:59.
Review.
Please enlarge your screen.
Vice. Yes. My paper is a review on protection of boiler steel tube with the thermal spray coatings from.
Your voice is not clear. Mr. Sukhjinder, your voice is not clear.
Am I audible, sir?
Yes, please continue. Please continue, Mr. Subhinder.
Sir, am I audible?
Yeah. Please
Yes.
continue, sir.
Am I audible, sir?
Yes, sir. Please continue.
Hello.
Please continue, sir.
The material temperature. Yes, sir. The problem of corrosion. Jaff and Jank had defined the corrosion of boiler steel is due to the oxidation of material at elevated temperatures. The coal used for the boilers contains sulfur, sodium, and vanadium and as an impurities. These impurities react with oxygen to produce oxides, which leads to a corrosion. The sulfur reacts with the oxygen, yields sulfur oxide, and further partially oxidized to SO3. Okay. Ilyas and others described the hot corrosion accelerated corrosion resulting from the presence of salt contaminants such as sodium sulfate, sodium chloride, vanadium oxide combined from molten deposit to damage the surface oxides of protection. The failure of either avoid at least detect the corrosion at early stage has resulted in many incidents resulting in the loss of material and deterioration in the addition to the direct cost arising from the shutdown or a loss of the productivity. Tens of the billions are spent routinely on the repair of boilers and their corroded parts. And even the risk of human life is there if they are not replaced. And moreover, there is a time-consuming task that it will take a time to shut down the boiler and to cool down the boiler. Once it is repaired, then come back to the normal position, then it will take very much time, and also the loss of efficiency is there. Traditional steels used through the thermal power plant can't withstand the problem of corrosion. In recent years, researchers have used various forms of coatings to improve oxidation and corrosion protection of steel. Thermal spray coating methods have become important means to improve the abrasive wear resistance, to improve the efficiency and life. Over the recent years, the coatings have gained the sufficient importance to improve the life of the steels in the high temperature application environments. These methods do not have any specific material limitations respect to coatings. High hardness coating can be developed in a few millimeters thickness. The methods of flame, arc, plasma, and HPO of high velocity oxyfuels are mostly used to protect boiler components. Next literature, Bala and others use a nickel chromium based coating and method used to deposit or for the deposition of coating. We use hot velocity oxyfuel methods. They concluded that nickel chromium coating was better resistance to the hot corrosion. Sidhu and others, they used vanadium and cobalt based coating, and the method used for the deposition was HVOF. They also suggested that with the use of this coating, there will be an improvement in the hot corrosion. Osaka and others, they use iron and chromium and nickel based coating, and the method used.
Your voice is not clear. I think your time is over also.
Mr. Subhinder, skip all these slides. Please skip all these slides.
Please conclude in next 2 minutes, sir.
Coating and these coatings.
Mr. Sukhjinder, am I audible?
Temperature survey the ceramic.
Mr. Sukhjinder, am I audible? Okay. I would like to just give you, am I audible? Just say your mic is muted. Sukhjinder ji, आपका mic बंद है.
Okay.
Sir,
Yes, sir.
what you have presented is not as good as we want. Since you have just given as a review paper, I think.
Yes, sir. Review
Yeah,
paper.
so it should be presented like some photographs or some research gaps which you have to shown in this presentation. I think session chairperson, am I right? It's
Absolutely.
yeah, I agree that it's a review paper, but there should be some research gap. Like you have shown the papers, all of the papers are.
Yes, sir, that is continuously that we shown that the porosity will be limited, or you can say while porosity will be decreased by using the different coatings. Okay. Every that research gaps are also shown that the from first that is from 1994 to present, the research gap is that we use the different coatings and we
So what is
use
the
some.
next methodology? What are you doing in the next your step? What is the next step of your research?
Actually, our aim is to decrease the porosity of the coating that so
Okay, sir.
that
Thank you very much. Your actually internet connection
that
is not much good.
Yes.
Yeah. So
the material which passes through the porosity to
He
the.
is not listening to you, sir.
Yes. We can move to the next presenter, sir.
Yes.
thank you, Sukhjinder sir. We will get back to you. Thank you for your nice presentation. Okay, thank you. You can stop your sharing, sir, please. Yeah, thank you, sir. So next is Mr. Ajay Yadav. Please be careful, presenter. The internet connection should be good. Okay, please take care of this. Yeah, Mr. Ajay Yadav. Mr. Ajay Yadav's topic is design of remote controlled land mine detection troops safety robot. I think it's a nice topic.
Sir,
Sir, Ajay
I'm
Yadav,
audible,
sir,
sir.
over to you. Your time starts now. It's 1:08.
Yes, 1.
Sir, I am audible, sir.
Yeah.
Yes, sir.
Good afternoon to all. I, Ajay Yadav, PhD research scholar from Department of Electronics and Communication Engineering, NIT Jamshedpur. And the topic of my presentation is design of remote control landmine detection troop safety robot. And the table of the content are as follows: introduction, metal detector, working of metal detector circuit, landmine detection technique, hardware design, metal detector, robot applications, and conclusion. A revolutionary intelligence system that detects explosive device hidden in the ground by using embedded system framework. The use of an autonomous robot to discover explosive in surface-laid landmines is becoming more common due to increasing death cases due to landmines. Hardware design and construction of remote control landmine detection troop safety robot scans a specified area and indicates the presence of landmines. When the landmine is detected within the range of robot, it produces a beeping sound and locates where the landmine is spotted. Introduction. Anti-personnel and anti-tank mine are two different types of landmines. Anti-tank mines are bigger with the diameter of 20 to 30 centimeter, where anti-personnel mines have a diameter of 5 to 15 centimeter. Anti-tank mines are often planted on the top of the ground, whereas anti-personnel mines are typically positioned under the soil and near to the surface. The weapons are most likely to harm civilians and the troops. Anyone who steps on the landmine has an 50% chance of surviving, and even if do they, there will be several personal and long-term damages due to the landmines. The metal detector. The operation of metal detector is based upon the principle of electromagnetic induction. Metal detector contains one or more inductor coil that are used to interact with metallic element on the ground. And this is the metal detector circuit which we have used in our project of the landmine detection robot. And working a pulse current is applied to the coil when the indicates magnetic field, when the magnetic field of the coil moves across the metal. The field induced electric current, that current is known as ED current, which due to the metal. The ED current indicates that their own magnetic field, which generate an opposite current in the coil, which induce a signal indicating the presence of metal in the range of metal detector. Now, the landmine detection techniques. There are several landmine detection techniques present, like biological, electromagnetic, optical, nuclear, acoustic, and mechanical. In biological landmine detection technique, we use dogs, bees, plants, and bacteria. These are used to detect the landmines. In electromagnetic landmine detection technique, we use metal detector, ground penetrating radars, and infrared for the metal detection. In optical landmine detection technique, we use visible light or LIDAR system, light detection and ranging. In nuclear, we use used to detect the landmine nuclear based. In acoustic, we use sound and ultrasounds for the landmine detection. In mechanical, we use the cleaning machine for the detection and the cleaning of the landmines. Out of which we have used the technique electromagnetic, in which the metal detection technique we have used to detect the landmine present. And this is the hardware design of our landmine detection true safety robot. This robot is controlled automatically by the microcontroller. The robot is propelled by the two internal DC motor to assist the motion. Each motor will be connected to a wheel that is linked to each other. When a mine is identified, the robot electrical system commands and robot to come to the halt and mark the area where the landmine is discovered or identified. At the point which we if we not get any mines, then this process will repeat again and again. It goes over the technique for using metal detector to help the robot to relocate the landmines. When the landmine is detected within the range of robot, it produces a beeping sound and locates where the landmine is spotted. This is our hardware model which we have made for this landmine detection technique. And this is the block diagram of landmine detection troop safety robot. This is the Arduino Nano through which we have connected the motor driver L298, and through motor driver the two motors are of the wheel of the robot are connected, and we power supply of 12 volt DC is also given. Through Arduino, the Bluetooth module is connected, and that Bluetooth module is controlled by external mobile device or laptops. And relay is also connected to connect the metal detector with the Arduino. And this is the block diagram. Metal detector robot application. There are the various applications of that metal detector, which can be used as detecting landmines. Robot are used in detecting mineral present in the ground. The robot are used for detecting the bombs, which are made up of the metal. And these can be used for in construction industries for locating steel bar in the concrete. They are used in airport and building security to detect the weapons.
The last 2 minutes.
Yes, sir. And now the conclusion. An overview of the landmine detection technique being given in this.
Mr. Arya, please conclude in next 2 minutes.
Yes, sir. Given in this project, there are several landmine detection techniques that can be used for this purpose. Each technique is suitable for detection under the some condition depending on the landmine and the material of landmine and the soil of that area. The benefits of landmine detection troop safety robot is that it minimizes the complexity by maintaining the ease of the robot. it is cost effective. The aim of the research to provide an idea for developing a robot that can detect a landmine, and from which there is the safety of our troops, military troops. A robot is capable of detecting landmine, taking out from their location where the landmine is located. The landmine is swiped out. And these are the references which we have used during this project. And thank you, sir.
Thank you very much. May I request to our associate chair, sir, any questions, sir?
No, very nice. From my side, it is okay.
Okay, thank you, sir. One question from my side. Since we all know that that landmine blast or explode whenever the high weight is applied over it. So, are your detector is able to do that?
Sir, actually, we are detecting that we are detecting metal. That our robot is detecting metal, but we have given one application of that metal detector in the detection of landmine, and that landmine is made up of, sir, metal. If that if our robot is going and in the area which robot is going, if any metal or any landmine is present, sir,
Okay.
it will
So
produce a heat.
it can investigate or find out any metals.
Yes, sir. Yes, sir.
It's very difficult, I think, so to differentiate between any metal and the landmine.
Yes, sir. Yes, sir.
So
For that we have to use cameras, sir. If we use camera in this robot, then we can see that
no,
either it is metal.
Landmines are already digging into the near the earth. Actually, it is digging into the earth. So how could the camera will capture that photograph?
Yes, sir.
And
That
how
is
it will
also a
differentiate
problem,
it?
sir.
This is the problem. I think
if we found any metal
should-
present in the surface, we should
topic
dig.
should be what is the topic basically? Design of remote control landmine detection, not it's a metal detection device, I think so. Right now it is showing like this. Okay.
Yes.
Thank you very much. Viresh sir, any question? Viresh sir, any question?
No, sir.
Okay, thank you, sir. So next is Mr. Shivam Mohapatra. Are you available?
Yes, sir. Yes, sir. Am I audible, sir?
Yeah, your topic is comparative study of Inconel 601, 625, 718, 825 super alloys during the electro discharge machining, EDM. Your time starts now. Please share your screen. First, please share your screen.
Just a minute, sir. Just a minute.
Next speaker is Mr. Vivek after Shivam. Please be prepared. Shivam Mahapatra, please share your screen. Shivam Mahapatra, are you there? Your mic is muted.
Yes, sir. Yes, sir. Just a minute, sir. Yes, sir. Sir, is this visible, sir?
Yeah, its time is 1:18. Time
Okay,
is 1:18. Your time starts now.
Good afternoon to all of us present here. My topic for today is comparative study of inconel superalloys during electrodischarge machining. And here are the list of contents: introduction, mechanical property, machinability, results and discussion, and conclusion. So introduction. What is a superalloy? Superalloy is a high performance alloy which in general has high strength at high temperatures, poor heat conductivity, and generate high heat while machining and are corrosion resistant. Also, it has low creep. And for example, the alloy which we are taking today is inconel super alloy, which is a nickel chromium alloy basically. So it has applications in various fields like aerospace industries, automotive industries, in which pipes, steels are made, the nuts and bolts, and petroleum industries. So here it is the mechanical property of all the elements in Inconel 718, 625, 825, and 601. And I have taken into consideration their density, thermal conductivity, modulus of elasticity, tensile strength, and melting point. The machinability. So for conducting the machinability test, I have taken into the consideration of the following criteria like gap voltage, peak current, pulse on time, duty factor, and flushing pressure with the notations as given in this table A, B, C, D, and E for each of the inputs, and their level variations as 60, 70, 80, and 90 for gap voltage, peak current as 5, 7, 9, and 11, pulse on time 200, 300, 400, and 500, duty factor in the intervals of 70, 75, 80, 85, and flushing pressure in 0.3, 0.4, 0.5, and 0.6. So in this level, we will be increasing or decreasing our following inputs to check the machinability. So the first one is Inconel 718. So the gap voltage, peak current, pulse on time, duty factor, and flushing pressure are all the input, and the output, what we are basically trying to observe in this Inconel are material removal rate, electrode wear rate, surface roughness, and surface crack density. So similarly for Inconel 601, 625, and 825. So basically it is observed that by increasing in the peak current, it resulted in improved material removal rate. So peak current, if we increase the peak current like 1, 2, 3, and 4, so the material removal rate are improving, like 5.8108 for here, 4.7038, 7.5709, and 2.5885, which is also improving, like 5.9707, 3.4432, 15.9951 likewise. Increase in the trend of surface roughness is observed for the increment in the peak current. Surface roughness, let's take the example of Inconel 601. So the surface roughness initially is 8.133, and then it increases to 10.2333, then it increases to 10.8000, and likewise so on. This is the trend for all the other Inconels, that it is increasing in trend: 7.6, 8.23, 9.86, 10.7, likewise. With all the increase in peak current, surface crack density tends to decrease, and again increasing trend. Like here in 625, first the surface crack density is 0.0281, but then it decreases to 0.0157, and then it again decreases to 0.0152, and then again increases. So first it decreases, then it increases. So this is the trend which was also observed in all other Inconel superalloys, like in 601, 0.0211, then it decreased to 0.0158, and further decreased to 0.0141, and then it also increased to 0.0189, then again decrease. So this increasing and decreasing trend was observed in surface crack density for various inputs of peak current. So the result which I observed was that it increase in the peak current is resulted in improved material removal rate, keeping the gap voltage, pulse on time, duty factor, and flushing pressure fixed at a constant value. And for different Inconel grades, as an increase in the trend of surface roughness is observed for the increment in the peak current. In the case of surface crack density with increase in peak current, the surface crack density tends to decrease, again followed by an increasing trend, and then finally remain constant. Due to high melting point, the Inconel 718 is widely used for the manufacturing of gas turbine and engine parts. Like we have earlier seen in that mechanical properties, 718 has a high melting point, 1370 to 1430. So it is suitable for the the industries which deal
Mr.
with.
Sir, please conclude in next 2 minutes.
Yes, sir. Yes, sir. Which deal in very high temperature, like ash handling industries, superheater tubes, due to its high thermal conductivity nature. In comparison to other Inconel metals, Inconel 625 has high modulus of elasticity as well as high tensile strength, due to which it finds its application in wire rope, underwater sea communication wire, because of its such mechanical properties. and Inconel 718 has highest melting point than other Inconel metals, due to which it is used in rocket engines and cryogenic containers, again, which has very high temperatures that generate during its ignition. Thank you, sir.
Thank you, Mr. Shiva. So you have given basically the comparison between 601, 625, 718, 825. So
Yes,
what is
sir.
the use of EDM in this case?
So the EDM was used to observe like which Inconel was means easily machinable and which produced the high heat basically. So according to
I
that, we
think
have
every you can easily find out the melting point of 601, 625, 718 from the internet also. So what is the role of that EDM? Just clarify this.
Sir, means yes, sir. You are right that we can easily find the all the melting point and heating temperatures of all the Inconel, but like in EDM, we are specifically seeing that what is the surface crack density or the surface smoothness with the
Okay,
along with the machine.
so you have applied an EDM to that particular material.
Yes, sir. Yes,
And
sir.
after that you have checked. Have you applied any optimization technique also? That which one is better?
Not yet, sir, but in the further work, I will be doing on that field, optimization
Oh,
techniques.
okay. Any question, Beresh sir and Ashwini sir?
No, sir. From my side, this is it.
Okay, thank you.
No, sir. Thank you.
Thank you. So
Thank you,
our
sir.
last presenter is Mr. Vivek Mansukh. The topic is influence of tool travel direction on micro hardness and tribological properties of AA2014. Mr. Vivek, are you there?
Yes, sir. Am I audible?
Yeah,
Yes, sir.
Please share it.
Okay, sir. Sir, is the screen visible?
Yes, yes. Please continue, sir.
Okay, sir. So good afternoon, one and all present here. Myself, Vivek Pragada, mechanical undergraduate from Institute of Technology, Nirma University. Now, one second, sir. Okay, so the topic of our presentation is influence of tool travel direction on tribological and micro hardness and tribological properties of AA2014 SiC CNT hybrid surface composites produced by multipass friction stir processing. So this is the outline of our presentation, which ranges from abstract till conclusion and at last references. Now, basically, in the experiment performed, we have prepared hybrid surface composite of AA2014 aluminum alloy with silicon carbide and carbon nanotube as reinforcement particles using FSP technique by altering the tool travel direction. And after that, we had prepared metallographic samples and had analyzed the effect of tool travel direction on micro hardness and tribological properties. So in the abstract, we can see that first of all, the material was chosen, and after that FSP, that is friction stir processing, was performed. And after that, metallographic samples were prepared to analyze the results. Now, so by referring the previous papers, that is based on literature review, we decided to prepare the hybrid surface composite of AA2014 aluminum alloy using reinforcement particles as SiC and CNT, and after that to investigate the effect of change in tool travel direction on the prepared surface composite. Here, the investigate word refers to micro hardness, optical microscopy, wear resistance, and coefficient of friction. Now, what is FSP? So FSP is a thermomechanical process of preparing surface composite of a metal through localized plastic deformation. Now, this method is widely used to improve material properties like tensile strength, hardness, fatigue, wear resistance, and also for the development of new materials. The workpiece attains superplasticity in this process. So the figure 1 here depicts the friction stir processing. We can see that the rotating tool is injected onto the workpiece in order to perform the friction stir processing on the workpiece. Now, the advantages of this friction stir processing are that it improves the surface properties and it doesn't change the properties of the base metal. This is the main advantage. And surface composites are prepared through this method. Now, mainly three process parameters are involved, that which are machine variables, tool design variables, and material properties. And machine variable includes tool rotational and traverse speed, tool tilt angle, and tool plunge depth. And here the tool design variable includes solder and probe diameter profile. And mechanical and thermal properties are involved in the material properties. Now this is the experimental setup on which we have performed our friction stir processing. So figure 3 shows the vertical head milling machine for performing FSP, which is at our institute premises. And figure 4 shows the FSP setup. That is, it shows the workpiece and how we had clamped that workpiece and how the tool was injected onto it. Now comes the selection of material. So we have selected 2000 series of aluminum because of its high strength to weight ratio and its applications in aerospace and automotive industries. And for the reinforcement, silicon carbide and carbon nanotube hybrid material is taken because, being a ceramic material, silicon carbide enhances the mechanical properties, while carbon content in carbon nanotube helps in tribological properties like wear and coefficient of friction. The workpiece that we have taken was aluminum plate having 300 cross 75 cross 5 mm dimensions, and the silicon carbide and carbon nanotube hybrid reinforcement particles were in the ratio of 50:50 with an average size of 10 nanometer. Now to inject these reinforcement particles onto the workpiece, holes were drilled with the help of CNC vertical milling machine onto the workpiece. Here we can see in the figure 6 that the holes were drilled of 2 mm diameter and 3 mm in depth. Now for performing FSP, that is friction stir processing, two types of tools were used. First of all, pinless tool was used to cover the holes and to have properly mixed materials. And after that, cylindrical pin tool was used to perform the friction stir processing. Here, rotational speed, traverse speed, and tool tilt angle were kept constant, and these parameters were selected based upon the previous study, that is based on literature review. And after that, FSB samples were cut out from the plate and then were grounded using emery papers of different grades, from P100 to P2000 to perform the metallographic samples. The samples then were sufficiently polished and were etched using killer reagent so that the grain structure can be exposed during microscopic experiments. Now following are the parameters that we analyzed, and these parameters we have taken based on the literature review. The parameters are microstructure analysis, microhardness, dry wear, and coefficient of friction.
Sir, your last 2 minutes.
Okay, so microstructure analysis was done using optical microscope to analyze the different zones prepared in the samples. The figure 9 shows the cross-section microscopy of different zones. Here middle figure shows the nugget zone and thermomechanically affected zone, and other figure shows the reinforcement particles. Then microhardness test was carried out on Vickers microhardness with a load of 0.2 kg and dwell time of 10 seconds. The maximum microhardness achieved was 141 in cross section and 165 in surface section.
Please conclude in next 2 minutes.
Okay, sir. Okay, sir. And this is dry wear characteristics. And then coefficient of friction was also carried out on disc and pin tribometer. So we can conclude. So based on this, following conclusions were arrived that the microstructure of the processed material enhances with increasing number of pass and altering the tool travel direction. Then by incorporating the reinforcement materials, it was observed that hardness was increased in first, second, and third pass. Then wear resistance for 3 passes were increased by 17.92% compared to second pass, and by 21.02% compared to first pass by altering the tool travel direction. Then also reduction in coefficient of friction was observed while change in tool travel direction, which resulted in improvement of friction properties. So from all the observations and results, it can be concluded that FSP enhances the hardness and wear resistance properties of base metal. And these results can be used for further research for further improvement. Thank you.
Thank you, sir. So I have some questions regarding your experiment. Like, you have used a friction stir welding for the welding of aluminum. We all know that
friction stir processing we have used.
Okay, friction stir processing. Okay.
Yes, sir.
So what is the difference, first of all, in processing and welding?
So friction stir welding, we joined two materials. That is, we joined two base metals. And in friction stir processing, on a single material, that is single workpiece, we reinforce some particles and then we carry out preparation of surface composite.
So you have created weld bead basically on
No,
that.
sir. We have created surface composite. We have used friction stir
Oh.
processing, not welding.
Okay. Clearly.
Yes, sir.
Okay. Thank you. So you said that micro hardness property is increasing by layer. I think you have found the highest hardness at the highest level. I think so.
Yes, sir.
Yeah. So what is the reason behind this? Is it the cooling rate of that particular metal whenever the processing?
So actually, sir, hardness depends on the homogeneous dispersion of the particles.
Okay.
That is how that also depends on the rotational and all the speeds that we have decided.
Okay.
Like we have kept it 726 RPM, so it basically steers the reinforcement particle and the base metal, and
Yes,
how
yes.
it creates homogeneous dispersion. So it defines hardness.
Okay. So what are the tribological properties you have selected basically?
So typological properties that we have selected are wear and coefficient of friction.
Coefficient of. Okay, thank you. Nice presentation, sir.
Okay,
And
sir.
any question, our session chair, sir? Ashwani, sir?
Yeah, very good afternoon to Mr. Vivek. It was very nice presentation from your side. I have just not so many questions, only one question I will ask. And you have choose aluminium as a base material, no? Am I right?
Yes, sir. Yes, sir.
Is it instead of aluminium we can use some another metals? What will be difference if we use instead of aluminium? Suppose that we will use zinc or some another metals.
Sir, surely we can use another metal. The reason we have chosen aluminum is because aluminum is widely used in aerospace and automotive industries because of its high strength and weight ratio, right? So here we have chosen 2000 series. 2000 series was used in aerospace, more widely used in aerospace, but nowadays 7000 series has overcome it. So we tried to improve that. If we can improve the properties of 2000 series up to 7000 series, so we can actually what we can say, we can purchase 2000 series at cheap rate and we can get the properties of 7000 series. So this is our main motto, sir.
If you have not found the aluminium, then instead of aluminium, which metal you will prefer? Instead of aluminium, if I say that during an experimentation, certain happened that you have not found the aluminium, then what will you do?
Yes, sir. We can use, I think, magnesium alloys we can use.
Why?
Because they are also widely used and they have similar, more or less similar properties, like we can say. Which
For example, what can I know the properties?
Sir, properties in the sense that we have investigated, like hardness, coefficient of friction, wear. So it would be easy to, we can say, on the magnesium alloys. And magnesium alloys, by doing reinforcement on it, it will largely improve these properties on magnesium alloys.
Okay. Thank you very much.
Okay, thank you, sir. Vivek, sir, one question from BTech student, that why welding is difficult on the aluminum process?
Sir, actually, there are many research papers on this also. It is a different research topic.
I just want to answer this question because whenever we do the welding on the aluminum process, there is an oxide layer forms over that aluminum.
Yes, sir.
Which the electron transformation doesn't take place. So it's very difficult.
Yes, sir. Welding is not done properly.
During welding, just use reverse polarity. This is the concept.
Yeah. The area is so close to Dr. Pravin, sir.
Yeah. Thank you very much. Okay. Thank you, Vivek, sir. Thank you, all the participants. Thank you very much, Ashwani, sir, for giving us such your precious time. Thank you, Ashwani, sir. Thank you, Beres, sir.
Thank you, sir.
Thank you, all the participants and co-host.
Okay. Thank you very much.
Thank you. One announcement for all the other participants that our next session will start from 2:30. So it's a lunch break. Please join that session from the 2:30 as mentioned in your schedule. Thank you. Thank you all.
Thank you.
I request to key host, Mr. Lalit.
Dr. Dhananjay, am I audible?
Yes, sir. You are perfectly audible, sir.
ललित जी, आपने सभी पार्टिसिपेंट्स को राइट्स दे दिए हैं ना, शेयरिंग राइट्स एंड प्रेजेंटेशन राइट्स?
सर शेयरिंग राइट्स तो है, सबको देने हैं क्या राइट्स या?
और जो लिस्ट आपके पास गया है, राइट, आपके पास लिस्ट है ना, मैं भी फॉरवर्ड कर
सर
देता
अभी
हूँ।
ज्वाइन नहीं किया उन लोगों ने, जो 5 लोग हैं उन्हीं को देना था।
अच्छा, मैं आपको एक लिस्ट व्हाट्सएप में फॉरवर्ड करता हूँ। दे आर ऑल द प्रेजेंटर्स फॉर टुडेज सेशन, काइंड उनको आप अपडेट
सर
कर
यहीं पे नाम बता दीजिए, मैं उनको यहीं पे कोहोस्ट बना देता हूँ।
ओके, जस्ट अ मिनट। वो है मिस्टर थॉमस वर्गीस,
वो बने हुए हैं सर।
मिस्टर प्रयास गुप्ता,
ज्वाइन नहीं किया उन्होंने सर।
ओके, आतिफ हमदन,
उन्होंने भी ज्वाइन नहीं किया है।
डॉक्टर अमित कुमार,
उन्होंने भी ज्वाइन नहीं किया है।
they have not joined. मिस्टर संदर शुक्ला
नहीं सर, उन्होंने ज्वाइन नहीं किया है।
एंड डॉक्टर अश्विनी कुमार,
ज्वाइन नहीं किया सर उन्होंने भी।
okay, so 3 people, 1 2 3 4 people have not joined. Okay. Dr. Ganesh, I hope. Dr. Ganesh.
Yes, sir. Good afternoon. Can you hear me?
Yeah.
प्रयास गुप्ता को कर दिया।
Okay.
ये तो कैमरा ऑन कर रहा है।
Okay, Lalit ji, I'm starting. Please keep it live. Good afternoon, everyone. I welcome you all to the second technical session of day one of ICMMIT 2022. We have with us today Dr. V. Ganesh and Dr. Dhananjay Pandey, who will be chairing these sessions, this technical session. And Dr. Ganesh will be giving his keynote lecture on the topic structural and morphological engineering of materials for biosensing and electrocatalytic application. Now, right after the keynote address by Dr. Ganesh, we'll be having presentation by the participants. So before I move forward, I would like to read the profile of Dr. V. Ganesh. Dr. V. Ganesh is currently working as a principal scientist at CSIR Central Electrochemical Research Institute, Karaikuri, Tamil Nadu. He has obtained his graduate degree and postgraduate degree in chemistry from Ayanada Janaki Ammal College, Shivakasi, and American College, Madurai, respectively. He has done his PhD from the prestigious Raman Research Institute, Bangalore, under the supervision of Professor V. Lakshmi Narayanan. After his PhD, he has carried out his postdoctoral research work at University of Edinburgh, Scotland. Thereafter, he joined CSIR Central Electrochemical Research Institute, and in the year 2009, he went to University of Manitoba, Canada, for a visiting research fellowship. Dr. V. Ganesh has contributed immensely in the field of electrochemistry, bioelectrocatalysis, bioinorganic chemistry, biosensors, nanotechnology, with special focus on biology and catalysis, which is reflected in his enormous publications of around 100 papers in reputed journals. Dr. Ganesh is also recipient of prestigious awards like CSIR Young Scientist Award in Chemical Science for the year 2014. He has also received Puthya Thalamulai Nambikai Nachathiram Award for Science and Technology for the year 2015, in addition to SAEST Golden Jubilee Young Scientist Award for the year 2015. He has 10 completed sponsored projects and currently having 10 sponsored projects going on. With his immense knowledge and in the field of electrochemistry and catalysis, I now welcome Dr. V. Ganesh to give his keynote speech on structural and morphological engineering of materials and biosensing and electrocatalytic applications. Over to Dr. V. Ganesh. I welcome you.
Yeah, thank you, sir. Thank you, Dr. Kunal, for your kind introduction. I hope I am audible, right?
Yes, sir. Yes.
Okay. Just give me a minute. I will share my slide. Then it should be okay. Okay. Are my slides visible now?
Yes, sir. Yes, it is visible.
Yeah. Okay. Thank you. Okay, very good afternoon to all of you. It's my pleasure to be a part of this international conference on materials, machines, and information technology, organized by, of course, ICMMIT University, Jharkhand. Before I start my lecture, I would like to thank Dr. Jayita for providing me an opportunity to share my knowledge in this August gathering, and also inviting me to deliver a lecture in this conference. So thank you, ma'am, for your kind invitation. I know it is very difficult to listen to lecture immediately after lunch, both in physical mode as well as in online mode. The online mode offers additional possibility of switching up the video and sleeping aram say. So with that, just jovial note, today I will be talking about structural and morphological engineering of materials for biosensing and electrocatalytic applications. Knowing the fact that it is very difficult to listen, what I will do is I will kind of give a flavor of what our research group is working on over the past 10 years or so, and during which I will try to convey some of the basic concepts associated with the topic. Okay, so before I start my lecture, let me tell you where do I come from. Since most of the students may not know about SICRI, this is called the Central Electrochemical Research Institute. It is one of the constituent laboratory of CSIR, Council of Scientific and Industrial Research. We do have two different subunits. Of course, the headquarters is located at Karaikudi in Tamil Nadu. And we do have two different units. One is at Chennai and the other one is at Mandapam. We are roughly about 300 employees, out of which 1/3 are scientists. And I can tell you that SICRI is one and only research institute in India devoted completely to the field of electrochemical science and technology. Right? We do look at fundamental aspects of electron transfer reaction across electrode-electrolyte interface, to material design to tune and modulate electron transfer reactions that occur at interface. And we do work on small prototype instrument and device fabrication for target applications. Okay, so in a short way, basically people are involved in a kind of multidisciplinary research approach. I will highlight the importance in due course of my lecture. And if you look at the history behind the establishment of such institute, the foundation stone was laid in the year 1948 by then Prime Minister Sri Pandit Jawaharlal Nehru ji, and it was declared open in the year 1953 by then President Sri Sarvapalli Radhakrishnan. And the person who is standing next to him is Dr. Sandiswarup Bhatnagar, who was the founder of CSIR. And the person who is in between these two is none other than Dr. R.M. Alhappa Chettiar, who was a well-known philanthropist, belongs to this part of Tamil Nadu. Thanks to him, he has donated 100 acres of land and 15 lakhs of rupees to establish an institute like SICRI in the year 1948 itself. Now, since its inception, it's been almost 7 decades. The contribution from SICRI both towards the fundamental aspect of electrochemical science and technology and towards the nation building is enormous. I can keep on list down the activities, but for time being, I would say that I repeat my earlier sentence again, that it is one and only research institute in India which is devoted completely to the field of electrochemical science and technology. Now, of course, Dr. Kunal has read out my biodata. Basically, I am a chemist. I do work on electrochemistry, which is my bread and butter. I do take concepts from material science and biology to come up with essentially sensors and devices, mainly for energy and environmental applications and for biomedical applications. So how do I plan to do this talk today, right? I will talk about why people are involved in doing research, probably my perspective, and I will give you some classical book-based definition of what sensor, biosensor is all about. Then I will introduce some of the basic concepts associated with electrochemistry and why it is important. Then I will talk about our own contribution to the field of tuning electron transport across electrode-electrolyte interface through a multidisciplinary research approach. And meanwhile, when we introduce different nanostructured materials, both in terms of structure as well as morphological engineering, what would be the effect it can bring in both in the field of biosensors as well as in the field of electrocatalysis. So that's the whole idea behind the plan of this talk. Now, so why do you think people are involved in doing research? It's not like somehow we got a job. It's like neither a banking or other kind of jobs where you go daily and count a number of rupees and you feel happy by looking at money. And over the period of time, it gets very monotonous and people may get even bored of it, right? On the other hand, doing research provides an opportunity to find solutions to the global issues. If you look at this slide, the humanity's top 10 problems for the upcoming 50 years or so are listed. starting from energy, water, food, environment, poverty, terrorism and war, disease, education, democracy and population, etc. I can give examples for each of these that it is going to be a problem for our upcoming generation. And how do we find solution to this? For example, let's take energy, right? Probably you would have heard that by 2030, the former Minister of Power, Piyush Goyal, he has mentioned that by 2030, all the vehicles on road in India would be of EV, electric vehicles. So how are we going to achieve this? Bringing both engineering and science aspect together, we can contribute and find solutions to this global issue. You take, for example, any village in the house right now, there won't be any houses without the following 3 items. The first one could be mobile phone, for example. Second, a two-wheeler, and third could be television. So how are you going to provide them continuous supply of energy in terms of both power, fuel, etc.? So which is going to be very, very critical. Like this, since I would be mostly talking on biosensors, disease, I don't have to even talk about it. We are literally visualizing the effect of diseases over the period of time. The recent pandemic has forced us to go from conventional mode of teaching to a completely non-conventional through online mode of education. Maybe when we were kid, nobody would have imagined having a class like this or an international conference through video conferencing, right? So that provides an opportunity for us to find solution. Now, apart from this, if you look at it, 2012, the human population across the globe was estimated to be 6 billion. And it is expected to grow roughly twice by the year 2050. So how are you going to accommodate all those people in this Mother Earth? How are you going to provide them green energy, good drinking water, healthy food, greener environment, etc.? The only way through which you find solution to these global issues is through science and technology. And that's where the dream of our Honorable Prime Minister, Sri Narendra Modi ji, would be realized. When you make a little bit step towards achieving solutions to these global issues, you can realize self-reliant India. And that's where people are involved in doing research currently. Okay. Now, understanding the chem-bio interface is very, very critical. Why? As I mentioned, for example, I would ask a series of questions. You guys don't have to answer it. Just think about it. Let's say we all have a good dinner at night and go to sleep, in bed. And who asked you to wake up in the morning? Maybe disturbance from your spouse, kids, mobile phone, etc. Let's say you wake up in the morning, and after 2 hours or so, when you get ready, you feel hungry, right? So why do you feel hungry? Who asked you to feel hungry? Let's say you take a good healthy breakfast, and after taking breakfast, you go to a bus stop or a railway station to catch a bus or a train to go to college or university, right? But when you look at someone, you feel very much irritated. But when you look at someone else, you feel very happy. Rather, you express your emotions like within a short span of time. Why do all these things happen? You guys would say that all these things happen because of biochemical reactions which occur in our body, right? I would go one step ahead and say that all these reactions happen because of electron transfer reactions which occur in our body. Some biomolecules would undergo oxidation or reduction, right? The moment such kind of redox reaction comes into picture, the study which deals with such kind of redox reaction is nothing but your electrochemistry, right? And other than that, I would give examples that why we need to understand how this chem-bio interface becomes very, very critical. Now, when I talk about electrochemistry, as I mentioned, the study which deals with electron transfer reactions that occur at interface, electrode-electrolyte interface, is called electrochemistry. In general, it can be categorized into 2 different areas, one in which voltage is applied to drive a chemical reaction, and the other case in which voltage is generated because of inbuilt chemical reaction. What do I mean by that? For example, let's say, suppose you have a wall clock in your home or so, The moment clock stops, what do? We simply change the battery, right? So that's comes under the second category, where the voltage is generated because of inbuilt chemical reactions associated within battery. The other case where voltage is applied to drive a chemical reaction. You would have looked at the recent literature reports saying that water could be used as a fuel to drive vehicle. Can it be really possible? Can we really use water as a fuel to drive vehicle? In that case, how do we do it? How about thermodynamics of water splitting reaction, right? Thermodynamically, water splitting reaction is not an allowed reaction, meaning delta G of that reaction is positive, non-spontaneous. On the other hand, through the simple Gibbs equation, like delta G Gibbs free energy equation, where delta G is equal to minus NFE, that's the powerful point of electrochemistry, where on the right hand side you can see N and F are constant for a given process. N is number of electrons, F is Faraday's constant. The only variable parameter here is E, which is nothing but potential. So the moment you apply a potential of, let's say, 1.23 volt, water could be split into hydrogen and oxygen. In a typical electrolytic cell, hydrogen evolves at cathode and oxygen evolves at anode. And that's how you can move from delta G, a positive reaction, to a delta G negative reaction. So that's where electrochemistry becomes very, very powerful. The other aspect of this is all the electron transfer reactions that occur at interface, typically the electrode electrolyte interface, solid liquid interface, metal solvent interface. The typical thickness of this electrical double layer is about only nanometer, right? I don't want to go into fundamental aspect of it, but I'm sure most of you guys would know the double layer structure and the various theories associated with the explanation of this double layer, right? The point I wanted to highlight here is, since the thickness of this double layer is of the order of nanometer, even if we apply a small voltage of, let's say, about 100 millivolt, right? The voltage felt at this interface is nothing but 100 millivolt divided by, let's say, about 1 nanometer, right? So which is 100 into 10 power 6 volt per meter. Do you imagine, which is a humongous kind of electric field that could be felt at this interface. And that's why electrochemistry is very, very powerful. You can carry out many reactions which are not possible by conventional chemical route. One can able to do that reactions through electrochemistry by applying potential. Because of these two advantages, tuning delta G, and the reactions occur within a very confined space of about nanometer. Now, okay. Now, let me spend a minute or two to tell you the classical book-based definition of what sensor is all about. Well, it is a device which converts either a physical or chemical parameter into a measurable electrical signal. In general, it comprises of sensing element, transducer, and the connected electronics. The glucometer, which is available in the market, is a typical example of an electrochemical sensor, right? So what do we do using that? You can measure blood glucose level by following an enzymatic reaction. You can prick your finger, take a drop of blood, place it on a flexible disposable strip where the enzyme glucose oxidase is immobilized. The moment the blood drop comes into contact with the enzyme glucose oxidase converts glucose to gluconic acid and hydrogen peroxide. The moment you insert that strip into a handheld device, you can monitor the quantity of hydrogen peroxide released either by oxidizing or by reducing at a fixed potential. You can do an amperometry reaction. And that's how the glucometer works. And you can see that such kind of sensor essentially consists of sensing element, transducer, and the connected electronics. The flow chart of a chemical sensor, as you can see, suppose you have an analyte which contains many different target molecules. You can pass through a filter. The recognition site would specifically detect the target analyte that can either change the concentration of ions, or it can modulate the electron transport, or it can result in change in temperature or polarization of light, etc. those changes would be picked up by transducer, and the connected electronics would convert into a measurable electrical signal. Now, in case of electrochemical sensor, again, as I explained, it is nothing but a device that interacts either chemically or electrochemically with the analyte, but the produced signal is monitored through electrochemical techniques. There are much simpler techniques like potentiometry, amperometry, and conductometry, where the measurement of either potential or current or resistance or impedance could be directly correlated with the concentration of analyte. Now, in case of biosensor, for example, you can either detect a target biomolecule, or you can use those biomolecules as a molecular recognizing element. For example, enzyme, antibodies, microorganism, or even a whole cell itself. Now, when the analyte binds to this recognition element, there could be changes in the concentration of electroactive substance, or there could be a changes in interfacial pH, or it can lead to changes in temperature, polarization of light, mass, etc. Depends upon what is the kind of parameter you measure through an electrical signal, you can term the sensors categorized into different categories. Now, I will also talk about our group contribution towards this. We basically worked on different kind of nanostructured material. As you can know that basically moving from a bulky metal where the conduction band and valence band overlap with each other, when you keep on reducing size of that material, essentially you will end up into a regime where the metal nanoparticles you can get, or when you go on reducing the size even further, it would end up with a quantized energy level. What we call as energy levels are quantized, where you can even literally count the number of nanoparticles, rather cluster of nanoparticles. Okay, so why this is important? Well, again, when you go on reducing the size, when the size of the particles are even smaller than the Bohr exciton radius, you would end up with what is called quantum dots, right? Why these things are very fascinating is because they can exhibit different kinds of properties. The main attractive one could be fluorescence, where compared to conventional semiconductor-based quantum dot, as you can see, the carbon-based materials can provide many different surface defects, where different surface states, meaning you can trap the molecule within the surface states, so that the emission from those states could lead to many interesting fluorescence behavior. Okay, so keeping that in mind, in our group, what we did was we basically just give me a minute, 1 minute. Keeping this in context, in our group, what we work on is we worked on developing biosensors using enzymatic kinetics by following enzymatic kinetics. So what we did was we have taken a simple electrode and one can tune the electron transfer reaction by introducing spacer. You can alter the chain length of the spacer, or you can modulate the electronic properties of the molecule in terms of introducing, let's say, aromatic or aliphatic ring. You can tune the electron transfer reactions that occur across the interface. Not only that, you can introduce nanomaterials, and the moment you immobilize the enzyme either directly onto the self-assembled monolayer or through the introduction of nanomaterials, the enzymatic properties could be altered. What do you mean by enzymatic properties? You can enhance the enzymatic reaction, or one can maximize the Vmax associated with this using Michaelis-Menten constant, or even you can lower the Km value so that you can able to detect a very, very low concentration of the target analyte. Now, when I talk about nanostructured materials, you can introduce, gold nanoparticles as simple as that, or you can introduce structures like nanostars, nanospheres, etc. Among these fascinating structures, basically we worked on gold nano stars. We have prepared this using a simple lyotropic liquid crystalline template-based synthesis. When you simply mix surfactant and water, you can get a variety of fascinating structures like micelle, reverse micelle, liquid crystalline phase, etc. Among them, this hexagonal pattern of liquid crystalline phase provides a confined domain, okay, provides a confined domain, aqueous domain for the reaction to happen. That's where you can control the core of the particle, okay. By altering the chain length of the surfactant, you can basically either enhance or shorten the arm length of the star. Why these things are critical? Well, this arm length variation could result in surface enhanced Raman scattering because it's a gold nanostructure. You can monitor the enhancement in the Raman signal, and that ACRS technique could also be used for sensing of analyte. So that's the one part we did parallelly. Apart from this, when we immobilize this on the electrode surface, you can maximize the enzyme loading. Thereby, you can alter the enzymatic kinetics associated with the reaction. Now, when I talked about quantum dots, carbon or graphene based quantum dots, we come up with a simple strategy, again using electrochemical technique, a simple electrolysis process. You take a carbon rod and a platinum, you do an electrolysis process using an electrolyte where depends upon the composition of the electrolyte and the time duration of the electrolysis, you can basically vary the resultant structure. You can play with a reducing agent. For example, you can introduce hydrazine, glucose, etc. Depends upon the chemical nature of the reducing agent. What we obtained was a homogeneous solution, and when you stir it, there is a precipitate which settled at the bottom, and there is a clear supernatant. Interestingly, when you shine UV light through the supernatant, you can see that these solutions emit fluorescence starting from dark blue, yellow, green, etc. On the other hand, the settled precipitate is nothing but reduced graphene oxide, and that could be used for energy storage applications. As you can see, one can quantify and analyze structurally what is the graphene quantum dot as a whole, and what are the structural and functional groups present on the surface of this quantum dot, so that could be used for further immobilization of biomolecule, right? Starting from enzyme using EDC-NHS coupling, or even you can directly estrify the functional moieties on top of this graphene quantum dot, right? And one can also see the quantum yield associated with these quantum dots. In fact, the yellow one exhibits a higher value of about 30% compared to blue and the green. Right. So this is what, of course, we did. Those fluorescent quantum dots we used for both biosensing and bioimaging applications. And for the settled precipitate, we use them for supercaps application as an energy storage device. Okay. Now, not only that, you can also prepare fluorescent gold nanoparticle, which is also, again, a unique one, because most of them exhibit a different structure or morphology of the nanoparticle. By using, again, enzyme glucose oxidase, the redox species associated with glucose oxidase, which is nothing but FADH2, flavine adenine dinucleotide, and its reduced component, right? You can use that redox moiety associated with the enzyme to reduce a metal gold salt into gold nanoparticle, right? And interestingly, it emits a beautiful yellowish green fluorescence upon shining UV light at 350 nanometer excitation wavelength. So in a way, we come up with a kind of multimodal sensing of glucose, since the enzyme are capped around these nano particles. You can use a simple colorimetry, or you can use fluorescence based technique, and by immobilizing them directly onto the electrode surface, these nanoparticles could be immobilized and organized on top of the electrode surface. As you can see, it exhibits beautiful redox peak corresponding to the enzyme glucose oxidase. And by looking at how the redox current changes with the change in scan rate, you can able to predict what is the quantity as well as the enzymatic reaction associated with the glucose oxidase. As you can see, we can basically load higher amount of molecules on the electrode surface and follow the enzymatic reaction by monitoring As I mentioned earlier, the glucose oxidase converts glucose to gluconic acid and hydrogen peroxide, and you can monitor the reduction of hydrogen peroxide using this enzymatic reaction. Now, a slight change in strategy, like when you alter the pH of such fluorescent solution, when you go to acidic pH, it exhibits a beautiful rosy red fluorescence, and when you go to an alkaline pH, it exhibits a green fluorescence. So by quenching such kind of fluorescence, we come up with a sensor, fluorescent-based sensor for amino acid cysteine. As you can see, this is very selective when compared to the other amino acids, as well as the biomolecules which coexist with cysteine, like ascorbic acid, aspartic acid, arginine, histidine, glutathione, etc. You can see it shows very selective fluorescence quenching in the case of cysteine. Now, the multi-mode of sensing comes by not only monitoring using colorimetric and fluorescence-based behavior, but also you can monitor using electrochemical techniques, right? You can immobilize these molecules and follow the oxidation of cysteine. As you can see, with respect to change in concentration, rather increasing concentration of cysteine, the oxidation peak current increases, and one can get a beautiful electrochemical sensor using this as well. Not only the current, you can also monitor the change in potential of the oxidation as well with respect to pH. Now, among the many different sensors what we developed in our laboratory, a while ago, we have come up with a novel concept of complementary pattern-based recognition receptor for a molecule like lipopolysaccharide sensing, right? This is LPS, which present at the outermost cell wall membrane of the bacteria, and it provides information about human immune response system. Okay, human immune response system. In general, it is a potent stimulant of immune response in mammalian system. If you look at the structure of such LPS molecule, it looks a bit complicated, but as a chemist, I am happy. You look at it, there is a long aliphatic chain, and there are functional groups one can target, and there are sugar moieties, so that we can create receptor for each of these components and bind the analyte effectively. Depends upon the concentration of LPS. Initially, it leads to organ failure, and ultimately it leads to what is called a septic shock, cell poisoning of the body. So what we did, by forming a self-assembled monolayer and gold electrode, and by using hydrophobic interaction, we can directly anchor this LPS molecule on top of the electrode surface. And once it is anchored, you can add a receptor, for example, phosphate group. We come up with a zinc-based complex, zinc dipyridyl amine-based complex, where it binds effectively to the phosphate groups of LPS, right? One can also add what are called the lectins, which is sugar binding protein. By the way, this LPS molecule is highly toxic because of the negative charges associated with the molecule. So when these receptors go and bind to this molecule, the negative charges reduces. Thereby, we can follow a simple electrostatic interaction based on how the impedance changes with respect to each receptor binding to the pattern. And we evaluated the efficiency of our sensor by using a natural binding agent like polymyxin B. As you can see, that binds only in the order of micromolar concentration level. And the strategy what we adopted, you can able to detect LPS as low as concentration even in the nanomolar range. Right. So in a way, we come up with what is called a complementary pattern-based recognition receptor. Right. You can assume this LPS molecule as a structural moiety with different patterns. Now, moving from a classical electrode-based sensor development to a flexible electrodes, which is a fascinating area, and recently many researchers jump into this field because of its potential in the area of biosensors. Now, what we did was about 5-6 years ago, we started working on flexible substrate like OHP sheets. Okay. Nowadays, I know all the faculties, they use PPT based teaching, But when we were at college, I remember our professor used to write in a OHP sheet and display, and such kind, which is nothing but a polymer sheet. You can reuse those polymer sheets by simply, cleaning with alcohol, etc. Again, we carried out a simple electrodeposition. Okay, carried out a simple electrodeposition. Of course, you can play with the conditions at which you electrodeposit, so that you can tune the morphology of the resultant deposit. And we demonstrated such kind of copper coated strips as a simple electrochemical sensor for glucose detection. You can monitor a beautiful amperometric curve with respect to change in concentration. The current basically increases, and it is selective because of the glucose oxidation which occurs selectively on top of this kind of flexible strip. A slight change in the modification strategy. For example, you immobilize a monolayer like mercaptopropyl trimethoxysaline on top of this overhead projector sheet, and you deposit silver followed by zinc oxide. Such kind of modified strip could be used for the pesticide detection. Here we have shown for what is called methyl parathion. Since this is an electrochemically active pesticide, you can simply monitor the change in redox property by following a DPV, differential pulse voltammetry, and correlate the change in concentration of pesticide to the current value changes as a result of interaction of this methyl parathion on top of the modified strip. Of course, we can validate and cross verify the sensor performance using a let's say another technique. Here we use the Raman based system to show that of course the sensor is selective to methyl parathion. Now that's about the sensors what we work on. Maybe I will highlight in the last 5 or 8 minutes, if it is okay. How much time I do have, Dr. Kunal?
Sir, you have another 8 minutes.
8 minutes. Okay, good. Yeah. So so in case of electrocatalyst, as I was talking about water splitting reaction, where by applying 1.23 volt versus let's say a reference electrode, you can split water into hydrogen and oxygen, right? And there are 4 different reactions in electrochemistry one would worry about. The first one is water oxidation. Next, let's say oxygen evolution, oxygen reduction, and hydrogen evolution reactions, right? Now, again, by using a simple electrolysis process, here in this case, we used titanium as anode and platinum as cathode. Again, by playing with the electrolyte conditions, starting from acid or base, or even you can introduce a salt in this, you can tune the anodization of titanium. Rather, it leads to TiO2 nanotubes. As you can see that there are beautiful ripple-based TiO2 nanotubes which forms during anodization, and deep understanding of the formation basically tells that the current density distribution varies, and that's why you get the combined nanotubes as well as a typical honeycomb-based structure because of this TiO2 nanotubes. And such kind of nanotubes, so we have demonstrated for both oxygen evolution and hydrogen evolution reactions. And compared to the one like platinum, we obtained about 40-fold enhancement in oxygen and 100-fold enhancement in the current density values associated with the hydrogen evolution reaction. Now, in case of conventional fuel cells, people use such kind of modified structurally engineered substrate as catalyst as an anode substrate. In our group, we also work on microbial fuel cell, where we immobilize microbes on the anode substrate. We can use a simple carbon paper, carbon cloth, etc. So that instead of the catalyst, the microbes would do the oxidation process, which is very fascinating because you can generate power from waste, and you can also convert the waste material into many useful products. So what we did was we have taken such carbon paper and simply electrodeposited nickel, and we immobilized Acetobacter aceti on top of this nickel coated carbon paper. As you can see, one can estimate how much loading of microbes could be done, depends upon the methodology we adopt. And that acetobacter aceti is selective to ethanol oxidation. You can see that when you don't add ethanol, in the absence of microbe, there is no current generated. But the moment, with respect to time, microbes are formed, okay? And after that, you add ethanol, there is a shoot up in the current. And that is essentially due to the microbes converts ethanol, oxidizes ethanol, and during this process, it releases electron, and that flows to the external circuit. Okay, so typically a single microbial fuel cell gives about 0.6 volt, and you connect them in series, you get about 1.2 volt, which is sufficient enough to drive a wall clock. And the power, the drawback of such microbial fuel cell is the lower power density. Okay. For example, if you want to demonstrate a working of a wall clock, a minimum of 10 microwatt is sufficient enough to run a wall clock. And this gives roughly about 150 microwatt per centimeter square area of the electrode. So you can basically run. And you can see that after about 150 hours or so, the voltage drops down. That could be because of two reasons. One, the microbe could be dead, or it may not have sufficient fuel to provide the potential, required potential. So after we add the ethanol to the system, it again shoots up, right? So that suggests the microbe is alive. It only needs fuel to regenerate the voltage out. Now, not just the wastewater, we can also use food industries waste, wine. With respect to fermentation, you get a higher amount of alcohol. Why food waste? Because of starch and carbohydrates, the microbes metabolizes through this carbohydrate digestion and provides you the electron output. Okay. Now, these are all typically some of the MFC assemblies what we have fabricated in our lab. What we work on currently is combining these two aspects. Okay. About 4 or 5 years ago, there is an interesting paper which came in Nature from Ali Javi's group from University of California. So he has proposed a wearable sensor for sweat-based analysis, right? The OHP sheet, what I showed in my earlier slide, we can basically screen print a multi-array of electrode so that each electrode could be used for a detection of single analyte. So what we, I will come back to that point. So that is one aspect. And by combining this MFC, instead of MFC, we use the enzymatic fuel cell reaction. What do I mean by enzymatic fuel cell reaction? Well, glucose oxidase again converts glucose to gluconic acid and hydrogen peroxide. During this process, electron is released, and that electron you can use to convert into a load. For example, we assembled an enzymatic fuel cell using glucose oxidase immobilized electrode at anode and bilirubin oxidase enzyme immobilized electrode at cathode, because this enzyme is very specific for ORR. In case of fuel cell, the cathodic ORR is a rate limiting step, and you can modify that ORR using this bilirubin oxidase, and that's how we assembled the enzymatic fuel cell system. As you can see, before you add any kind of fuel, the open circuit voltage is as high as 0.93 volt. And the moment you add the fuel like glucose, the enzymatic reaction starts occurring. So the output of the assembled system is about 0.43 volt, and you can get a reasonable the power density and the current density. So what do we do with this? Well, we can basically use this for sweat analysis, and that's where we are currently working on. I mean, when I talk about sweat, scientifically that is called perspiration, which is an interesting concept. There are two conditions under which individual would sweat. One, temperature difference. The other one is emotional change. If someone comes and proposes to you suddenly, or if your teacher comes to the class and tells you that today is going to be a surprise exam, you can see some of the students would start sweating, right? But interestingly, the constituents of sweat, for example, like lactate, urea, glucose, chloride, Na+, provides information about our health status. So the idea is to develop a multi-analyte sensing platform, electrochemical sensing platform using the array of electrode, what I showed a bit earlier, so that the individual electrode of the array could be used for the detection of individual analyte like lactate, urea, glucose, and chloride. Well, where do we use this? Well, we can extend this to both the defense and sports arena, where you guys would know that, for example, like during Olympic, what do? We announce a person to be, let's say, #1 gold medalist during this 100-meter race. And after 3 or 4 years, you say that that person is being tested positive for, taking a drug or so. So what's the use of it? By then 4 years, he would have already been got enough sponsorship money, etc. And when you ask back the gold medal, he would be more than happy to remove and hand over to you, right? So that's the kind of scenario we are in. But we can impregnate, we can modify the fabric material using this multi-array electrode, so that while running itself, he would sweat, and you can monitor the change in such kind of biomarkers. Okay, so that's the idea behind it. Of course, finally, to conclude, I have given the overall view of what our group is working on, assuming that you guys are researchers and you would know the fundamental aspect of it, right? So you would believe me, and also agree with me that electrochemical science and technology is a fascinating subject. And by taking a multidisciplinary approach, by taking concepts from material chemistry, biology, etc., you can come up with the different sensors and catalysts, essentially to lead a happy life based on smart material and a smart sensing system. So of course, to do this, we need a multidisciplinary group effort. And in that way, I think this conference plays a vital role, because it's not just a pure chemistry or material based concept. You are also integrating with the information technology and engineering aspect, so that people who listen to it could easily correlate the concepts and the interdisciplinary nature of research as a whole. So finally, I thank once again you all for patience listening, and I would be happy to answer any questions, queries, or suggestions you may have. Thank you. Thank you very much.
Thank you, Dr. Ganesh. Dear participants, if you have any question, you can kindly ask. I believe, sir, there are no questions. Thank you, Dr. Ganesh, for your enlightening speech, giving a comprehensive information about the use of biosensors in determining the bioanalytes, use of the biosensors in determining cases of septicemia, to use of the same in agriculture sector and addressing issues of environment concerns. We are really blessed to have you, sir, today. Now we'll have the technical sessions where the participants will have their presentations. So in this regard, dear participants, I would like to give you a couple of information. Please kindly restrict your presentation to 10 minutes, where 8 minutes will be of actual presentation and 2 minutes will be of question answer session. And I will give a reminder with, I'll ring bell at 6 minutes and again at the end of 8 minutes. Please kindly restrict to your presentation and follow the time span. Okay. Moving forward, now I request Mr. Thomas K. Varghese.
Yes, sir.
To give his presentation on the topic carbon fiber reinforced medical implants.
Am I audible?
Yeah, Mr. Okay. Thomas, please carry on.
Okay. Good afternoon, everyone, and a warm welcome to everyone present here. Thank you for giving me an opportunity to present my work in this conference. So my topic is carbon fiber reinforced medical implants. As the word says, it definitely depends upon the carbon fiber work. So I'm gonna, the list of contents. This is an introduction. I'll give you an introduction. The ongoing development, like the current things, we need to look into all these orthopedic surgeries, all these traumatic injuries, because these are very serious. So even if the existing components or existing materials are not it will not provide sufficient abilities to treat all the same. We need to look out for new materials to improve improve these surgeries. So the existing components such as titanium, COCR alloys, surgical steels can be replaced with CFRP because, as you know, carbon fiber reinforced polymer has high strength to weight ratio and also very low volume and comparatively high rigidity. So speaking of that, these are our objectives. I'm not going to find the suitable metrics because carbon fiber itself, I mean, the carbon dust is a problem for our body, but carbon fiber, since it's combined, it's does not cause much of problem. So the basic methodology, CFRP can be prepared by many methods like hand layup, other methods are VARTM, etc. We used hand layup in order to reduce the cost, and also it's an easy accessible method. And also first fiber is placed on the mold, then the base resin is with catalyst, mixed with catalyst is poured on, and we spread it across using a slider. And then upon we add another layers, this process is repeated until required layers are met. Also, tests should be conducted to evaluate the features or evaluate the properties. The detail I'll rush through. We have a lot of details, so I'll rush through it. Literature survey found that carbon fiber can be used with a suitable metrics, can have high strength and biocompatibility. Studies were conducted, then theoretical studies on the lamination sequence. Lamination sequence is a very important part to reduce bending, extension, coupling, extension, shear coupling, and bending, twisting. Then a failure of composite with volume. Volume also critically plays a role in this thing. Before we went on to the carbon fiber, we practiced in order to, we went on to practice on the glass fiber because carbon fiber is really expensive and getting hands on it is tough. These are the ratios in which we mix the resin to catalyst. Like there are two resins, types of resins we use: epoxy based and catalyst based. Catalyst based, in order to harden, catalyst required is much lower, as you can see, 1000:14. But in the case of epoxy, it comes about 30%. So we use similar to what we are going to do on the carbon fiber, 8 identical layers. In this thing, first attempt was random. Then the second attempt, we used 6 layers because we need to understand our capabilities. We used the volume fractions, we measured the mass, and then we calculate to what extent we can reach. That's how we arrived to 0.565 and mass fraction. Mass fraction of matrix means mass of the matrix divided by mass of the composite, total composite. So total number of layers is 8, as said. Then these are the procured materials. We use different types to experiment on, these are the data sheet, the properties of the fiber and the resin, cured resin, to be precise. Then items price. Okay, in this we calculated, as I said, we acquired the 0.435 and 0.565 from earlier result and from our training. Then we reverse calculated all the mass of the matrix and the mass of the fiber which we needed to. Also epoxy to hardener, as I said, epoxy accounts almost, a hardener accounts almost 30%, 33.3% mass of the epoxy. Then we used bidirectional carbon fiber and number of layers and lamination sequence. This is particularly to be taken a note of because the symmetric means 8 layers. This symmetric means it is repeated, like minus 45 minus 45 minus 45 45 45 minus 45 minus 45 45. So that's why it represents. It's similar to that. So we built that composite, like short video, like difference. We cut that all and just skip to the part. Okay, so this is where the major of our work comes, the L, T, T dash. These are 3 mutually perpendicular direction. L represents along the fiber. T represents across the fiber, and T dash represents the direction which is directly perpendicular to both of the L and T. As I said, F represents fiber, M represents matrix, C represents composite, V is equal to volume fraction. And rho equal to density. Volume fraction, how we derived into this equation, it's a general equation, it's already given. So we, total volume of the composite equal to volume of the matrix plus volume of the fiber. So dividing the volume of the composite with throughout, we'll get 1 equal to Vm plus Vf. So we can calculate rho density in a similar manner. And mass fraction also the same equation. It can be related, extrapolated to this equation. This is where the longitudinal modulus comes place, or the elastic moduli. We need to find the elastic modulus of the. This is only for a single strand or a single sheet of fiber mixed in cured resin. So EL equal to VF cross EF plus VM cross EM. VF and VM are volume fractions of the fiber and volume fractions of the matrix, and EF and EM are elastic modulus of the fiber and elastic modulus of the matrix, which is given in the data sheet. So load sharing of the composite equation is also given. Similar equation can be used to find the transverse modulus of the composite. Transverse means across, as I said, ET. Because since the above equation cannot be extrapolated to ET, we can use a different equation founded by Halpin-Tsai relation. That is, this is the thing. This is the equation. Eta equal to is given, and the zeta or zeta equal to 2 is for circular fibers. There are rectangular fibers, so it will come by A by B, 2A by B. I mean, launch. Okay, so the shear modulus equations are given. The Poisson's ratio also to find the equations are given. Then the bulk modulus of the composite, this are used to calculate this. All these equations are used to find out the Q matrix. Q matrix are a stress strain relationship. So Q matrix equation Q11, all these individual values are given here. Then Q bar matrix represents when the fiber is oriented at a different direction, we can use to find the Q bar matrix like stress strain relationship. And the C and S represents cos theta and sin theta respectively. And then general sigma, this, as I said, this is a similar equation, stress strain relationship. Q bar represents the scaling or multiplying factor. So this is where the total composites feature depends upon Aij, Bij, Dij. This is the equation for finding out all of these things. And this is the final result. We can't stress strain, I mean, like create a relationship because all these metrics, all these fibers or all these individual laminas are and arranged together. So it varies, the fibers varies. Since it is an orthotropic element, composite is an orthotropic element, it will only act have similar properties in a single plane. So we can only find the resultant force, moment, and mid-plane strain and mid-plane curvature relationship. So optimization, as I said, it is similar to FCC. 78.5% can be the maximum amount of fiber. This is where the optimization work comes in. Like this is a similar graph. The small downward portion is because very low fiber can cause only stress concentration, which in turn can reduce the total longitudinal modulus or the stress to a lower, because as I said, stress concentration. For laminate, as I said, 45 minus 45, 45. Earlier, looking into that equations, we can see sin theta, cos theta. So every part will have a counterpart, almost Aij. Some A23, A32 will have a counterpart which cancels out and become the zeros. That's how we reduce the extensional stiffness, coupling stiffness, etc. So then this is where the lamination level. These are the results, but not very promising in the glass fiber, not very useful. This is the carbon fiber itself manufactured. Then mathematical modeling, we have got the results of the mathematical modeling. Then PF by PCET, all these individual components. This is also Q matrix. Then this is the final result. Final results is where we want to improvise it. So we optimized it because we are not capable of achieving that. NX, NY, NXY. We are not.
Mr. Thomas, kindly conclude in next 1 minute.
Okay. We are not, as I said, we are not able to achieve that kind of experience. So we can theoretically find out these answers. And this, you have to note this point 6.166. This is an abacus model. We created a similar in the abacus model in order to prove our result. So this is the optimized model results. I will show the next. You can see this forces, all these distributions has severely increased with 78.5. As I said, 78.5 is the volume fraction. That's how we optimized it. Then the minimum stress was found to be 0 MPa for the exact same sheet. So discussion, it was found that the properties in the direction fiber depends mainly upon the properties of the matrix, and the fiber properties. Volume fraction also plays an important role. Then with changing VF to 78.5% can drastically improve the features or the properties to high level strength. Then scope our future work, we can try out with different metrics. The similar equations can be used for different matrices or say different combinations. Then conclusion, since HANLAP is a simple method, it has few limitations like matrix place, low product quality. It was also found that volume fraction of the has sustainable impact on the composites mechanical characteristics. The direction in which this load is applied should be considered while creating the design of the composites. Thank you. These are our reference. Thank you.
Thank you, Mr. Thomas. Now I ask Dr. Ganesh if you have any questions to ask to the participants. Dr. Ganesh.
Okay. Thank you, Thomas, for your nice presentation.
Thank you, sir.
So did you check the basic requirement of carbon fiber being used in medical implant? I think.
Yeah, actually, basic requirement was checked. I mean, we checked, as I said in the beginning, carbon dust is a problem, but carbon fiber itself can't cause because it's binded inside a matrix. That's why we are using a matrix, which will help aiding the outside. I mean, finally, the matrix will be the part which will be in contact with our bones or any part of our body, which can aid in reducing the significantly reduce the effects, drastic effects of carbon fiber.
Yes, yes. Okay, thank you. Yeah, thanks.
Thank you, sir.
Next, we have a presentation by Mr. Prayas Gupta. He'll be presenting on design and analysis of curved recess honeycomb structure piston. Over to Mr. Prayas Gupta.
Yes, sir. Am I audible?
Yeah, you're audible. You can share your screen. Can you restrict your presentation to 8 minutes?
Yes, sir. Good afternoon, all of you. I am Prayas Gupta, BTech Automobile Engineering student from Galgotias University. Today, I am going to show you my work on design and analysis of curved recess honeycomb structure piston. So basically, piston is a very important part of the engine, and it plays a lead role in the working of an engine. There has been a lot of research work done in this area where designer makes some changes in the design and investigate what effect on the object in different manner, i.e. solid structure, thermal and model analysis also. So there is a list of contents, introduction, design and modeling, and after that we conclude the result and conclusion. Introduction. The present study is carried out to investigate the effect of modification for the piston with curved recess. Honeycomb structure made up of aluminum alloy on the piston head. Finite and element analysis were used to calculate the allowable stress in the piston. Structure analysis was performed on to calculate the one mass stress, deformation, shear stress, and maximum principal stress. Design and modeling of the piston with curved recess honeycomb structure. Standard piston dimension calculated by the analytical using the engine specific data by using the Grashopp's formula. Aluminum alloy used in the model, and standard piston and curved recess honeycomb structure model made in SolidWorks 2016. and maximum material properties taken from the reference number 2, which is mentioned in the last 1 mm thickness of the hexagon and 1.5 mm depth from the top, as you saw in the figure. ANSYS 2001 used for finite element analysis. Structure analysis is performed on the both of the piston model. This is a solid model of the piston, and this is the curved recess honeycomb structure with curved recess tube. 0.15 mm flit is provided at the edge of the curved recess to prevent the stress concentration. So we are going to result discussion. First we conclude the one mass stress. The stress generated on the curved recess honeycomb structure piston has been reduced by 23.57% up to 14.97% from the standard piston model value of 19.6 megapascal. Second, this is the deformation. Providing a curved recess honeycomb structure piston had reduced total deformation approx 5% from 2.4408 into 10 to the power minus 5 meter to 2.346 10 to the power minus 5 meter. Third one is the maximum principal stress. The curved recess honeycomb structure piston provide a 22.13% drop on maximum principal stress as compared to the standard piston from 84.72 megapascal to 65.97 megapascal. Maximum shear stress. Curved recess honeycomb structure piston provide a 18.16% drop in shear stress compared to the standard piston from 52.997 megapascal to 43.375 megapascal. 80% reduction is a good reduction, which assured you that piston has very less chance to fail in shear compared to the standard piston. And so we are going to conclusion. The resulting stress can be safely absorbed by the piston. There are safely absorbed by the piston. The measured stress for an aluminum alloy is 114 megapascal, which is calculated by analytically, which is less than permitted allowable stress 122.7 megapascal, which is taken from the reference number 2. One mass stress reduced by 23.57% and deformation is reduced by 5%, and maximum principal stress reduced up to 22.13%, and shear stress is reduced by 18.16%. And these are all references. Thank you, sir.
Thank you, Mr. Prayas. Dr. Ganesh, if you have any questions, kindly do ask.
Maybe one question, if it is okay. Yeah. Prayas, good, focused work. Did you look at why hexagonal or honeycomb-based structure gives such deformation? What's the reason behind? Yeah.
Because this study on basis of biomimetic basis, and hexagonal shape is actual shape which is made by honey, which is made by honey for honeycomb. So and it is very reliable, and it is have a very good strength to absorb pressure loads. So
okay.
This shows the less deformation compared to the solid surface.
Maybe like in terms of higher porosity or surface area of the material, that adds to the property, I guess, the absorption. Yeah.
Yes, sir.
Yeah. Okay. Thank you. Yeah.
Thank you, sir.
Thank you, Mr. Prayas. Now, Mr. Atif Hamdan will present his work on consequential development of internet and its conclusive impact on people and economy and Indian perspective. Over to Mr.
Yes, sir.
Sandeep. Kindly restrict your presentation in 8 minutes.
Yes, sir. Sir, is my presentation?
Yeah, it is visible. It is visible.
Okay. Greetings, everyone. I'm Atif Hamdan from the Department of Civil Engineering, ICMMIT University, Jharkhand. And today my topic is consequential development of internet and its conclusive impact on the people and economy and Indian perspective. This is the list of contents and introduction. The topic of my paper is based on a rather simple fact that a sensational digital change in India, which did not even take a decade to transpire, revolutionized the life of common Indians. This change is so significant that the United Nations Development Program, which regularly publishes Human Development Index, is now willing to consider internet services and internet connection as a parameter to measure the standard of living of individuals. The jump from keypad to Androids and from reluctant to send SMS to organizing such great international conferences, we have come a long way. However, it did not just happen by God's will, but telecommunication and broadband communication bandwidth had a major role in it. Thus, the objective of my paper is to interpret the statistical data to analyze growth, scope, cause that resulted in the exponential increase in internet users in rural and urban India, to discuss the variable consumption and distribution pattern of internet in terms of age, gender, and the diversified service provider market industry of India, and to review the impact of internet on culture, economy, and its role of in pushing the countries towards a developed and socialized culture and a cashless society. And at last, to provide a regression model of the statistically interpreted data sets of internet users and telecommunication sector to give a wholesome context and conclusive result of the positive about the positive hypothesis. For an efficient analysis and detailed perspective to be conveyed through our research study, parameters need to be selected. Now, although our slide shows the possible parameters are suitable parameters, however, on analyzing the data sets, we came to the conclusion that it portrayed a rather narrow perspective, and hence a broad and much versatile effective parameters need to be selected. Thus, our parameters of research were selected as shown in the slide. We first compared the growth scenario of internet in India with the situation around the world. Later, we went in depth to analyze the distribution of internet, the consumption pattern, the consumers' patterns, and the different diversity of the services provided. We then moved into review the influence or impact of internet on economy, culture, and the contactless payment system market, which have been very evident in recent years. After critically analyzing the records and data sets, the following inferences were derived from the selected parameters. From the internet development of the world scenario, we find out that 1.5 billion users were added within a span of 5 years from 2014 to 2019, and approximately 60% of world population is now using internet and its related services. This is evident in the case of India, where 1.6 billion mobile phone subscription 1.6 million mobile phone subscription, among which 776.45 million were internet subscribers. This is 3 times the record observed in 2014. On moving further to analyze the various parameters within the context of India, for the gender, age, and consuming behavior, we observed that 70 to 30% ratio of representation of male and female was seen. But while analyzing the age range of Indian users, we observed that out of the 504 million effective users using internet services for more than 5 years, 433 million users were above the age of 12, representing a large population of internet users were the young generation, that is children. The consumption of data and user consumption pattern of India was found out to be 12 GB average per month in 2019, which is 157 times the data of 2014, which was 62 MB. This is rather significant, as China, which has only 5 GB average, and South Korea, which has only 8.5 GB average, and our digital economies have yet very less consumption pattern comparing to India. The distribution and connectivity of India was observed that out of the 776 million internet users, 98% were wireless subscribers. Among them, 55
and 44% were rural and urban subscribers, indicating towards a digital divide which still existed in the country. For the different wireless providers, after analyzing the data sets, we found out that the Bharti Airtel, Reliance Jio, Vodafone Idea, BSNL were the major players which covered the telecom market, where Jio covered the maximum, that is 32.99% of the market share. We then went on to analyze the influence of internet and its impact on the economy of India. Our statistical estimate suggested that development in the telecommunication service by 1% boosted the economy by 3%, thereby resulting in the growth of economy of the nation. We also connected the culture and entertainment sector together, where we believe that what people see is what they behave. And we also analyzed that the OTT platform, that is the content that can be accessed using internet, have a similar rise with that of the internet users, that is since 2014. The e-payment system, or the UPI, Unified Payment Interface, which is now very evident among us now.
Kindly conclude another 1 minute.
Yes, sir. At the end of analyzing all the observed data, we then went on to validate our data with our regression model. That is, we validated the tele-density adopted to determine the tele-density, which represented the measure of the framework of telecommunication sector. We used it for the ordinary OLS regression model method, and the result of the correlation came out to be positive 0.929, which is close to 1, representing strong relationship. Where on the other side, we used the Pearson coefficient of correlation method and used as the dependent independent variable as the GDP and internet users, and the correlation also came out to be positive to near to 1, which signified that our hypothesis that internet has a positive impact in India was verified. Thus, in conclusion, this paper presents a collected data sets of the observed data, verifies it through the means of different mathematical regression method, and provides a base platform for further studies of predictive modeling and the revolutionary changes that may transpire in the country in future. Thank you, sir.
Thank you, Mr. Atif. Now I request Dr. Ganesh to kindly ask questions.
Thank you, Adip, for very useful work. I just have, out of curiosity, I was thinking, did you add any pandemic to your predictive model? Because
yes, sir. Yes, sir. Yes, sir.
It is from 2014, I guess. Yeah.
Yes, sir. No, sir. So, sir, we aimed for we analyzed the data sets for from 2010 to 2020, but focused from 2014 itself. However, we realized that for the e-commerce payment system, the rise of e-commerce payment system was coherent with the rise of the demonetization and later with the pandemic. So the data signifies that due to pandemic, the e-commerce payment system was very evident, and that's the result which can be seen today.
Yeah, because it is very much useful. The data
yes, sir,
you
for
collect
the
and
contactless
predictive
payment.
modeling. Yes, absolutely. And
yes,
also the use of mobile phones, after the age of 12, that would have also added, increased percentage would have resulted in due to pandemic as well, I guess.
Yes, sir.
Yeah.
Yes, sir.
Okay. Thank you. Thank you.
Thank you. Thank you, sir.
Thank you, Atif. Now the next presentation is by Dr. Amit Kumar. He'll be presenting on stochastic patronage modeling for performance assessment of a manufacturing unit. Over to Dr. Amit.
Okay, sir. Thank you. My screen is sharing, sir.
Yeah, it is seen. Kindly restrict your presentation to 8 minutes.
Thank you, sir. Myself, Dr. Amit Kumar from STT University, Mechanical Engineering Department. I'm going to present my paper titled Stochastic Patronage Modeling for Performance Assessment of Manufacturing Unit. I will be covering introduction, literature review, program formulation up to reference. Now, the main goal of the industries is to maximize the output with the existing resources. And the major problem is the shutdown of components and major and minor faults in the component. So they do not perform their intended task because a number of faults can affect the performance, and these accuracy, the inaccuracy in the maintenance may also be the cause of shutdown and the failure of the component. And this complexity in the maintenance accuracy can be resolved by performance assessment and optimization of parameters or maintenance parameters of those components which are intended to perform. But it is very difficult to predict when the component will be under failure. It can be find out by the history of the components, and the maintenance department can give you the data where you can find the failure and repair rate or failure frequency and repair frequency of the component, and how much time is taken to repair the component. So I will not explain the literature review, so because time is very less. So what is the research gap? I will come into it. In the different peoples have worked on this performance analysis and behavior analysis, reliability and availability analysis, but few of them have worked on these kind of paint manufacturing industries, and the people have also presented their models theoretically, but they do not use the real working environment and condition in their variable setting. We worked on the paint manufacturing industry. Nobody has worked in this, and our parameterization of the variables are highly influenced by the real working environment. So my objective of research was to study the nature of various industrial systems and subsystems along with the failure characteristics, to collect and translate the available maintenance data, means in failure and repair rates, to conduct the mathematical formulating through the patternate modeling method, and to identify the criticality of various subsystems there which are responsible for the low productivity and shutdowns. So present study work plan is similar, and then we have used the patternate modeling method for the analysis. And this the patternate modeling method is important because a number of components can fail at the same time in this kind of modeling method. And the performance assessment have been carried out by varying the variable data, and then we have find out which component is highly critical and which is highly sensitive after changing the failure and repair rates in the component. The performance assessment in this, we have used GIRF 2008.15 X35 simulation package, and we have used we have run the plant for 20,000 hours with confidence rate of 95% and virtually. And this is the basic model of patternate, where P is the places of the component, T is the transitions, and these white transitions are time-based transition, and like black transitions are quick immediate transitions after satisfying the logic. We have to write the logic for this, and for before starting the analysis, we need to have some assumptions. And first is failure and repair rate are constant and statistically independent. Performance-wise, repair unit is a good unit and very good and like a new component. Subsystem never degraded with time. Sufficient maintenance facilities available. There is no waiting time. All the units are initially operating and working state, and the system may work as the reduced capacity state. The notation we have used in the model are circle for the places and white rectangle for time transition, black rectangle for immediate transition. They have own guard function, and when the guard function is satisfied, they act immediately. That's why it is called immediate transition. And dot is the token which moves from one place to another place according to time transition and immediate transition. And arrow defines the direction of movement of the token. So this is the model, and where 1, 2, 3, 4, 5 machines are installed. In machine D and machine E have two machines in parallel to perform the work on higher rate. And these are the objective functions which satisfy or which operate the immediate transitions. Whenever the failure rate moves the token from one place to another place, the immediate transition activate, and in this way the dynamics of the patterned model works. So the time is very low. I cannot explain thoroughly. So this is the results we have performed when we run the plant virtually.
Conclude in another 1-2 minutes.
Okay, sir. Okay. We have changed the failure and repair rates from 0.5 to 0.11 like this. And we have also compared the patterned modeling result with Markov model in order to verify the results. We can see the availability of Markov model is less than the, patterned model is less than the Markov model. But at the same time, we can say that in patterned model, there is a provision of failure of two components at the same time, or two or more components at the same time. But in Markov model, one component can fail at the same time. That's why the availability of the patterned model is less than the Markov model. And the availability provided by the patterned model is also realistic. And in this way, we can see the behavior of A, B, C, and D components so that we can find out highly critical component. You can see the D1 is the highly critical component, which is decreasing or increasing the availability with higher rate. And this is the effect of number of repair facility. If we increase the number of repair facility, the availability is increased from 1 to 2, but then it becomes constant because there is no effect of a number of facility more than 2. And this is the conclusion. And now in this simulation model, we can achieve higher performance with various preventive measures suggested to the maintenance personnel for each subsystem based on their effect on availability. So we can observe different components, and the subsystem B is most critical. We have identified, this is mistake, it is D. And although Markov model gives better result, but in reality, 2 or more subsystem fail at the same time, and the patterned model can deal with multiple failure in the system simultaneously. Further increasing the repair facility up to a certain limit, its effect provides the closer behavior of the system performance. It can be concluded that the patterned modeling method provides realistic results. So limitation of this study is the failure and repair parameters are constant in present study. The result may be more realistic with variable failure and repair rate parameters. And the other factors like system cost analysis, safety analysis are not considered in this study. And there are very important factors of industrial point of view. And the computational result clearly demonstrate the effectiveness, and it can therefore be used for analyzing the behavior of repairable system in higher sensitivity zone. And the number of redundancy allocation method have been proposed in the literature and may be good option to reduce the effect of random failure in the performance. And certainly provision of redundancy component will increase the system cost, and the optimization to acceptable operation and maintenance cost at the same time as the system availability. The time varying failure and repair rate parameter may be the good option for more realistic result. So that's why that is all from my side. Question, please.
Thank you, Dr. Amit.
Thank you.
Now, thank you for your participation at ICMMIT. Now I request Mr. Sandar Shukla to give his presentation on simulation of residual stresses and thermal distribution in T-shaped joint. Over to Mr. Sandar Shukla.
Yes, sir. Good afternoon, sir. Good afternoon, everyone. My screen is visible. Hello. Hello.
Yes, your screen is visible. Kindly share your PPT.
Okay, sir. My name is Chandra Shukla. I'm from Department of Mechanical Engineering, Calcutta University. And my topic is simulation of residual stresses and thermal distribution in T-shaped joints. They are the list of content that I have discussed. Introduction. What is primary? We have discussed about the welding. What is welding? Welding is a normal fabrication process that join the material by heating them and suitable temperature with or without the filler materials. Quality of weld be determined by the following factors: geometry, mechanical property, and the shape of structure. And the welding process localized weld zone. And in this paper, I have used the tech welding because tech welding is a small welding which is used to hold the part together, because tech welding are small and temporary welds that hold the part together until the final welding completed. In this welding, I have used the seam welding because seam welding is requiring high toughness and the waterproofness and easy to operate. Maximum utilization of current and minimum pollution has been created. And in this paper, I have two main cause of distortion. Distortion have been caused by two ways. For first one is normal uniform expansion on contraction. If the temperature is applied on the material, the expansion and contraction process has been applied. And the internal stresses. Internal stresses are basically the inbuilt property of the material, which can be react with surroundings or not. Purpose I have to study, because I have to study in welding distortion for the sequence of shape, magnitude, and structure in steel plate shape deck structure, to understand the contraction and expansion and the mitigation of temperature distribution over the whole material property. Distortion is a very challenging problem in industry to reduce, because if uh, if we joint any material parts, the material property increases and they are the heavy weight and it cannot be shrink in the ocean. And these are the list of papers I have studied during the process of research. First one is study the effect of welding sequence on ship deck structure. They have used the methodology of finite element modeling and thermal simulation. Material they have used the flat bar stiffener of a steel plate in ship deck structure, and their outcomes are based on the numerical finite element method. Second one is the effect of paper parameters and welding sequence on residual stresses. They have same uses the property of a finite element method, but they have extra is mechanical simulation. They have changed in the material property of A16061 T6 aluminum alloy. They have uses the ANSYS software to represent the finite element method of temperature distribution. And third one paper is the advanced structural technology method to reduce distortion. They has uses the methodology of traditional gas tungsten arc welding, and they have uses the material thin walled structure made of steel dimension, and they are the dimension of thickness, and the outcomes is be structural and technology changes. And these are the fourth paper investigation, the effect of process parameter and mechanical property and distribution. They uses the fiber laser welding.
Mr. Sandar, sorry
Yes,
to
sir.
interrupt you. Please
Sorry,
kindly
sir.
move on to your result discussion and conclusion, because we are
Okay.
running short of time. Kindly do that. Okay.
Okay, sir. Sorry, sir. In my paper, I have uses the three properties: finite element method. Finite element method, I have studied about the thermal history field, thermal equations, and stress-strain relationship, and thermoelastic plastic deformation and displacement field. In finite element method, I have to solving the equation of mathematical modeling. And second one is the thermal analysis. Thermal analysis is basically the temperature distribution on the working process of geometry parameters and the pre-processing of the geometry, and thermal analysis, which what process external force is applied on the geometry and the causes of the transition state or temperature distribution. These are studied in thermal analysis. And third one is welding sequence. Welding sequence is a very important property because in we have used the welding sequence because sometimes uh, in uh, in this figure A, we have to study, we have to weld in same direction because the material property is very high, rigid, and they have to sustain the temperature. And in this property C, we have to alternate the property because the temperature changes, the heat affected zone increases, and the property of the thermal temperature changes. Due to this, material hardness will be less. And these are the results I have to conclude. The temperature at the different sequence. Sometimes temperature will be changed because of temperature heat. Sometimes will be heat will. Sorry, sir. The effect of temperature distribution at different of sequence welding. There are the minimum or maximum points. These are concluded in the flat T-shaped joints and residual stresses generated in the welding sequence. Maximum and minimum welding equals maximum and minimum welding sequences of solid model and shell models. These are the conclusion I have to concluded. The distribution of both temperature should be coherent. Deformation of the welding sequence can be minimized without any special equipment. The weakening pattern has much more subsequent effect on distribution, such temperature of maximum. So weakening sequence is much more significant than the residual stresses. Average displacement assessment good criterion to find the satisfactory sequence of welding. Choosing an optimization welding sequence can provide the lowest possible deformation. And these are the references I have taken from my paper.
Thank you, Mr. Sandharv Shukla, for participating in our interaction conference. Thank you very much. Now we'll have a presentation by Dr. Ashwini Kumar.
Yeah,
He'll be speaking on interfering of liquid fuel droplets burning approach. Over to Dr. Ashwini Kumar.
Thank you, Dr. Kunal, for inviting me. Just I want to share my screen.
Yeah, please.
Just a minute. My screen is visible?
Yes, it is visible, sir.
Thank you. Thank you very much.
Kindly restrict your presentation within 8 minutes.
Sure. So, good evening to all the respective dignitaries and the organizing committee. This side, Dr. Ashwini Kumar from the Department of Mechanical Engineering, SDT University, Gurgaon. Today, I am just going to give a short brief on interfering of liquid fuel droplets burning approach. The list of contents will be comprises of starting from the introduction to the reference sections. So for the introduction part, the steady state mass burning rates of interfering fuels droplets have been determined experimentally by a porous spheres simulation model. So ethanol has been used as the liquid fuels, and experiments has been carried out in both the stagnant and the convection ambulance. So the mass burning rates of the two interfering droplets separated in the directions of perpendicular to and the long direction of airflow have been investigated. So by concluding this, the results have been compared with those of the isolated single drops. So the actual attributes of the copywriting show are similar to the mass copy rate, the shape and the length of the fire, and the temperature appropriate inside the fire not really settled and the constant by the course of hotness, mass, and force transfer between the vibe and the fluid fuel beds establishing the splash. Hence, the laws of the drop burning are needed as the essential data for the comprehension and investigation the course of the explosion ignition. So this work is mainly endeavor has been made to in the current work to anticipate that tentatively by the permeable circle reproduction method, the constituent state mass consumption pace of two modeling fuel drops in the both vertical and the descending wind streams. So coming upon the experimental investigations, the main objective of the experiment was to determine the steady state mass burning rates of the two interfering liquid fuel droplets. In this, the ethanol was used as the fuel, which was fed up with the porous sphere of 6 mm diameter from a sari with a plunger being advanced at a constant rate by a speed control motor screw arrangement, which was metered quantity of air, which was admitted by the means of wind tunnel fitted by the Mackey-Habrus nozzle, which have the exit diameter of 25 mm. The droplet interface was investigated with the two spheres kept in two different configurations. The first one was the side-by-side configurations, where the spheres were separated in direction perpendicular to the direction of flow. And the second was the upstream downstream configuration, where they were separated along the direction of flow. The second configuration was experimented with both upward and downward airflow. The two spheres had independent fuel feeding arrangements, and the inter-drop distance was also varied to determine the interface effect in terms of the inter-drop distance. Along with this, one last thing was that the fuel feed rate was also determined from the reading of the voltage of the motor during the piston, and then from a calibrated relationship of motor voltage with the rate of change of a piston displacement. And the steady state burning rate of the fuel was measured as the feed rate of fuel, the sphere at which a stable flame could be maintained by keeping the surface of the sphere wet without any dripping of fuels. In the results and discussion part, there we have the two things. First one is the single phase sphere experiment, and the next one is the burning characteristics of interfacing drops. In the first part, we have the burning rate and the shapes of the flame for a single drop burning in isolations in convective convenient ambience depend upon the direction of flow, whether upwards or downwards. In an upward air flow, the buoyancy induced flow due to a natural convection, which helps in the forced convection. So under these circumstances, the shape of the flame is almost similar to that in an increase with increasing airflow. So in a case of downward airflow, the buoyancy induced flow opposes the forced flow, and the resultant effect causes the flame to assume the shape of hat. It has been found that in the present study, the mass burning rate at a given airflow rate is always higher in upward airflow than that in downward airflow. Of single fuel drop, and this can also be explained from the viewpoint of flame standoff ratio, which is lower in case of upward airflow. For this formula was used as was formulated by the Nusselt number, and Nu is equal to mh by d Tf minus Ts, where the small m was denoted by the mass burning rate, Hf was the latent heat of vaporization, d was the diameter of the porous sphere, the Ts was the surface temperature of the sphere, and the Tf was the flame temperature, and finally the K was denoted as the thermoconductivity of gas surrounding the sphere, which was thermocouple with the help of temperature, which was measured by a platinum 10% of RF thermocouple, which is coated with the silicon dioxide to minimize the catalytic effect. Depending upon the second side, it was divided into the two parts. The first part was the side-by-side configuration, and the second part was the upstream downstream configuration. The first was when the two droplets interface, the total mass burning rate is reduced as compared to that of the two isolated drops. This reduction is inversely proportional to the interdrop distance. Depending upon that, as you can see in the figure number 1, which is showing the interfering droplets of side-by-side configuration with the upward airflow. In this figure, it is assuming that the consuming of drops is partially even when they are isolated by the distance of the evenly formed on a spout pivot, the hub of the balance of the stream, towards the path opposite to the streaming hub. The varieties of the mass consuming pace of the modeling circle with the x by d ratio. Here x by d ratio is nothing but it is the proportional of division distance to the circle width. Similarly, the old data of the figure 1 has been illustrated in the next table number 1. Similarly, the second portion was the upstream downstream configuration. As you can see in the figure number 2, it is showing the mass burning rate of upstream droplets with the air flow, which follows almost the same pattern as that of the single isolated drop. So the variation of the mass burning rate of the downstream drop with the interdrop distance in an upward airflow for
Kindly conclude in another 2 minutes, sir.
Sure, sir, sure. Different values of the Reynolds number is shown in figure number 2. Similarly, we have the last but not the least, the third figure and the table in the similar way, which is showing the behavior of the downstream of the droplets in a downward airflow. So depending upon the conclusions on the basis of the above discussions and results obtained from the following major conclusions have been met. The first one was that it has been found that in the present study that the mass burning rate of the air flow rate is always higher in the upward flow than that of in the downward. It has been found that for the higher values of Reynolds number, it has isolated the droplets of the seam to be lower for the side-by-side corresponding. The values of the airflow are higher for the even higher values at the number of the upstream downstream configuration. And the last, the comparison of the mass burning rates between the isolated droplets and interfering droplets in the different configuration used in this study, it reveals that the effect of droplets interface on the mass was more pronounced of the upstream downstream configuration as a side-by-side configuration. So it can be concluded that there is a study between the, so to show the found the higher values of Reynolds number, to show the higher values of the upstream and the downstream configuration by side. These are some references which has been used during the study. So thank you, and it's over from my side. Thank you, sir.
Thank you, Dr. Ashwini. Now I request Dr. Ganesh to kindly ask the question. Over to Dr. Ganesh.
I don't have any question. Thank you.
Thank you very much, Dr. Ganesh.
Thank you, Dr. Ashwini. Now this technical session 2 ends here. Now we have another technical session lined up in the same virtual room where we have Dr. Diago from Portugal as a keynote speaker. So I request the participants to attend that technical sessions too. With this, I conclude this session and I thank all the participants for joining to this international conference and hope to see you again in upcoming conferences. With this, may I request Dr. Ganesh to permit us to close this session.
Thank you, sir. Thank you for the opportunity. It is a wonderful session. Madam, now only I'm seeing you, though we have emailed and corresponded. Okay,
thank
nice.
You, sir.
Thanks for the information, invitation. Thank you, sir. Thank you, Dr. Dhananjay as well for chairing this. Thank you. Thank you, Dr. Gunal.
Thanks, sir. Thanks. Now I request the IT host to temporarily close this virtual room so that we can have the next technical session at sharp at 4:30. Thank you.
The room is open. You can leave, sir.
Okay. Thank you.
Anyway, I am calling, ma'am.
Yeah. Okay. I think Akshay is there.
Yes, one is there.
Yeah.
Akshay is there, right? Vikram is also there.
Yeah. Akshay, sir. Am I audible to you, Akshay sir?
Yes, sir. You are audible.
Okay. So in that case, I'll request you once take your presentation.
Ma'am, I hope Vikram is not here. No? Vikram is here. Vikram is here.
Okay, sir. It is visible now.
Yes.
Okay. Okay. Thank you. Now you can unshare.
May I start, ma'am?
Akshay sir, no, you have to wait, sir.
Okay.
Sir, Vikram Mane sir, she will be joining within next few minutes. Okay. BD sir, so in that case, whether we can start the normal technical session, and once
I
Diogo
hope, ma'am. I hope
yeah.
we should start. Yes, ma'am. That will be the more appropriate.
Okay. Okay. Good evening, all the dignitaries and participants present here. And as our plenary speaker, Dr. Diogo M.F. Santos is yet to join over here. So by the time we can start our technical session. This technical session is consisting of total 8 papers. And we can start with Mr. Kaushal Kumar Singh. And I think he is there.
Kaushal Kumar Singh.
Yeah, he's
Mr.
there.
Kaushal, are you here?
Lalitji?
No, ma'am. No, actually have a telephonic conversation with him, ma'am.
Yes, sir.
Mr. Kaushal Kumar Singh has.
Yeah, Kaushal Singh, is there.
Okay.
I request Mr. Kaushal Singh to share your presentation.
Okay, ma'am. Just a 1 minute.
Yeah.
And some maximum time within 8 minutes, you have to complete your presentation with conclusion and each and everything.
Mr. Kaushal Singh. Yeah. Please put it in slideshow mode.
Mr. Kaushal, you are muted, I hope.
No, sir.
Please.
Sorry to interrupt. I think our plenary speaker, Dr. Diogo, has already joined. Dr. Diogo, am I audible to you?
Hello.
Yeah.
Sorry
Hello.
for the delay.
Yeah.
I still have to.
Biri sir, so in that
Yes,
case,
ma'am.
we can start
Requesting.
with the,
Yes.
our speaker's presentation.
Yes.
Right?
This is the request to Kaushal Kumar Singh. Please, we will take your presentation after the. Yes.
Please stop sharing.
So please, sir, stop sharing your PPT.
Hello. Should I start?
Yes.
Before you starting, shall I introduce you?
Okay.
Yeah. This is Dr. Diogo M.F. Santos, and he is an invited assistant professor at Instituto Superior Técnico and researcher in the Center of Physics and Engineering of Advanced Materials, studying electrodes and membranes for application in direct liquid fuel cells. DMF Santos was born in Torres Vedras, Portugal in 1977 and graduated in chemical engineering at IST in 2001. He received an MSc degree in 2006 and a PhD degree in electrochemistry in 2009. His PhD thesis was devoted to the development of the direct borohydride fuel cell. He did a 3-year postdoc in chemical engineering in FEUP and IST, studying new electrocatalytic materials for hydrogen production by alkaline water electrolysis. Afterward, he did a 2-year postdoc in material science and engineering, developing cathodes for direct borohydride fuel cells in IST and CICECO. As an investigator, FCT in CFEMA, from 2015 to 20, he developed low-cost electrocatalyst for low-temperature fuel cells. DMF Santos has authored over 120 journal papers and 90 conference proceedings. His current H index is 30 in Scopus. He has presented more than 50 oral communications and 80 posters at international conferences. He is a member of several renowned international societies and serves as a reviewer for over 80 different scientific journals. He is currently the supervisor of 1 PhD student and 1 MSc student. He has completed the supervision of 1 postdoc researcher, 1 PhD student, 17 MSc students, and 10 research internships. His research interests are related to electrochemical energy conversion and storage. A very warm welcome, sir. And now you can start your presentation.
Thank you very much for the presentation, Dr. Jaita. It is a pleasure being on this conference. I really want to thank you. Thank you for inviting me to present here today. I brought a talk on something that we are working for some years in our group, which is on the use of electrochemical engineering for bridging the gap between academia and industry. So this is a picture of our group in Lisbon University. The group is led by myself and Dr. Šljukić, but for some years I am trying to find some projects with the national companies in which we can use our electrochemistry knowledge to solve some problems of the national industry. So on this approach, I'm collaborating with some people from the group, with here Lourinho and Oliveira. They are co-authors of the works that we've been done in the projects that I will present today, and also Mateus, which is not in the picture because she was the one taking the picture from all of us. So this is a nice image for us because it was the last time that we could be all together in the conference just before this pandemic started. So these are good memories from what we had before, and we hope that soon we can have them again. So what are the approaches that we are proposing for these electrochemistry-based approaches to solve basically old problems, to get new solutions from old problems from the industry? The general approach that we're following on this electrochemical treatment of wastes is based on the use of electrolysis for application on these wastes from the industry. Basically, on the cathode side, we want to have the hydrogen evolution reaction to produce hydrogen, which is a clean fuel with high calorific value. And on the anode side, we want to have the oxidation of compounds that are there, either for its destruction, if they are pollutants for the degradation of the organic load, or for conversion of those compounds to high value added products. That's another approach that can be used in some of these wastewater. So the development of these electrolyzers, if properly designed, it's a low investment, and they can be environmentally sustainable processes when renewable energy is used. So we can use solar or wind energy to power these electrolyzers, and by that we have a greener process. So in our lab, how do we propose these solutions? We use conventional electrochemical techniques based on cyclic voltammetry, linear scan voltammetry, chronoamperometry. These are the basic electrochemical techniques that we use to get fundamental information, to carry out these fundamental studies and determine several kinetic parameters that characterize these processes. For example, on cyclic voltammetry, we can get kinetic parameters on the oxidation processes, and then get information on the number of exchange electrons, on the charge transfer coefficients. This is what we normally get related with the anodic process. As for the cathodic process, which is the hydrogen evolution reaction, we use linear scan voltammetry to get the Tafel coefficients, the exchange current densities, these parameters that allow us to understand better the process. Then we use small scale electrolyzers, and we normally evaluate the stability of the process by chronoamperometry. What we do is, like, we apply different voltages, or we apply a given voltage after optimizing with the other two techniques, and we apply a given voltage on the electrolysis, and we follow the current with time. That's why we call it chronoamperometry. We follow the current with the time, and in the end, we do the analysis of the electrolysis products. So we try to evaluate what is the effect of given applied voltages on the wastewater under study. So for these experiments, we use normally these simple 3 electrode systems, which always have a counter electrode, working electrode, reference electrode, and we do the tests of each, we study what is occurring in each electrode, and then in the end, we do these electrolyzer tests in which we have a cell with the 2 electrodes, and this is a different approach where we use a power supply to evaluate at a slightly larger scale. So this is what we do in most of our electrochemistry-based approaches. Now I will talk a bit about one of the projects that we have ongoing, and this one is with the Navigator company. The Navigator company, it's a very important Portuguese company. It's the world's larger paper producer for printing paper, and we have this project with them on the valorization of black liquor from the pulp and paper industry. Black liquor is a byproduct of this pulp and paper industry. Just to show you how this black liquor shows up. So on this industry, we have first this milling of the wood chips, then we have the wood cooking, then the pulp goes for washing, and after washing, the pulp goes for further processing, then to produce the paper. But from this washing, we have the generation of this weak black wood liquor. This weak black liquor is the one that we are working on. It has water, it has the cooking chemicals that need to recover, and it has lignin. Lignin can be a very important product, can be sold if properly recovered, and this is where we are working on. Currently, what happens in the industry, what they do is they do the evaporation of this weak black liquor so that it goes to strong black liquor, so with a higher dry solids content. After it is more concentrated, much more viscous, then it goes to a recovery boiler for energy production. Basically, they burn the lignin, and by burning it, they generate electricity, and they recover the cooking chemicals. So it's called the green liquor, then goes to causticization and has the white liquor and goes back into the wood cooking. This is what is done now. What is the problem with the current process? This is the recovery boiler where they produce energy, and this is the main reason for changing the process of black liquor recovery. During peak production, the volume of the black liquor often exceeds the capacity of the recovery boiler, which leads to an interruption of the pulping process. So sometimes they need to stop because there is too much black liquor going to the recovery boiler. What they have asked us was to reduce the amount of volume to go to this recovery boiler and use an electrochemistry-based approach to treat some of the black liquor. So the idea would be like to shift about like 5% of this flow of black liquor and use this black liquor to recover the lignin and at the same time have the valorization of this byproduct. So what we proposed? We proposed the electrolysis of this black liquor. Our proposal involved the production of hydrogen from the black liquor, just from the reduction of the water of the black liquor for the hydrogen production at the cathode. And on the anode side, we proposed the oxidation of lignin for the recovery of lignin from this black liquor. So this is a simple concept with low investment, and that could treat some of these byproducts, then to produce the hydrogen for several applications and to extract the lignin from that black liquor. So what did we start by doing? First, we did the characterization of the black liquor. It has a very good ionic conductivity. The pH is highly alkaline, around 12.8. And these physical properties of the black liquor allows us to use it as an electrolyte solution. It's an aqueous electrolyte solution. So it had all the properties that allowed us to do electrochemistry on this electrolyte. First, we started by analyzing the electrochemical behavior of the black liquor, and we see it has a very nice cyclic voltammogram with very two well-defined oxidation peaks. No reduction peaks, but these two oxidation peaks. So this shows us that there are compounds on the black liquid that are easily oxidized at relatively low overpotentials. This is a big advantage. On the other side, on the cathode side, we see that the hydrogen evolution reaction also occurs at not so very high overpotentials. So we can also produce hydrogen from this black liquor solution. So for example, instead of producing hydrogen in alkaline water electrolysis from simple KOH solutions that are currently used for hydrogen production, we can have black liquor electrolysis also for hydrogen production and at the same time have the extraction of the lignin. So it seems a very good proposal. The company was very interested and we got this project and started by testing different electrode materials for the reactions. So this is just to show you how we explore the different materials. For example, we tested iron currents were very low. It was immediately rejected. We also did some tests just on glassy carbon, just to test how it behaves. It shows the activity, although with low currents, but it shows the oxidation of the lignin. Here with lead, we had higher currents, but the lead itself was oxidizing, so we also were not interested. We had some interesting results with tin, but we're not following with that because the materials that had the best activity were exactly platinum and nickel. Of course, platinum is very useful for us to understand the electrochemical behavior, but we're not planning to use platinum, as that would make an electrolyzer extremely expensive. We are just using this for fundamental studies. Nickel is a material that is widely used in the industry. It's very low cost. It led us to high current densities and at the same potentials as that of platinum. So nickel was the material that we selected for the electrodes of this black liquor electrolyzer. We also tested stainless steel. Stainless steel is also quite used in this industry, but it had very high over potentials for the oxidation of lignin, so we abandoned the use of the stainless steel. So we also tested the nickel for the hydrogen evolution reaction on the black liquor. We tested some other materials for comparison, and you can see here that the nickel gives much better cathodic currents for the hydrogen evolution reaction. So just to summarize this work, we started by doing this characterization of the black liquor. These properties, good ionic conductivity and alkaline pH, told us that it had good conditions for the use of electrochemical methods for its treatment. Then we tested different electrode materials. Nickel was the one that was most promising, both for the anode and for the cathode of this electrolyzer. And currently what we are doing, we have passed to a small-scale black liquor electrolyzer. We are doing this in a bigger cell. We started first with very small vessels. Now we have built in our workshop an electrolyzer which has a volume of 9 liters of black liquor with recirculation with a pump. And it's now working much better. We can have simultaneous hydrogen production and collection, and the oxidation of the lignin. And we are currently using this 9-liter electrolyzer. Just to tell you one small thing I didn't mention, as the hydrogen is the only gas being produced in the electrolyzer, because on the anode side we don't have oxygen generation, only the lignin oxidation. This is a big advantage because we don't need to use membrane separators between the two electrodes, and hydrogen is the only gas being generated, so we are able to produce high purity hydrogen because it's not contaminated with oxygen, as it happens in conventional electrolyzers, where oxygen and hydrogen are produced simultaneously. In this case, we have the oxidation of the organic compounds at the anode, so only hydrogen is being produced at the cathode, and only hydrogen is being produced in the cell. So this is a big advantage. So I will now move to a second project with industry. This is a project that we have with a cement company, Cecil. It's a very big Portuguese cement company. This project is on it's called Clean4G, on the conversion of CO2 from cement production into a clean gaseous fuel. We know that carbon capture technologies will be key for emission abatement in cement production, especially during the calcination process. The project it comes from previous projects. It builds on previous projects that were done on this Cecil company. First, there was this Energreen, where they built a pilot unit integrated in a biorefinery that was using different biomasses to generate biofuels. with high calorific value from this novel liquefaction process. So they were using these biomasses, and by thermal liquefaction, they were producing biofuels. This was the first project they did here. Then they after this green, they had this alpha green, also related with the bio oil production. And then we moved to this clean 4G, which is the most recent, and it's currently ongoing. So what is the scope of this clean 4G? Like, there are two approaches we are involved with the electrochemistry based approaches, but there are other groups using catalytic approaches on the process. One of them is related with the methanation of the CO2. So what they do is to do the reaction of CO or CO2 with hydrogen to produce methane, and then the methane can be fed back to the cement company for energy generation. So the idea is either to have this approach in which they are working on, or in our approach, we are using the bio oil that is produced in a company, but from that liquefaction process, and we are trying to do the electrocracking of this bio oil. So basically, we are trying to break the bio oil into smaller chains to produce added value compounds, and at the same time, on the cathode side, also having the hydrogen evolution. That is one of the approaches. The other approach is having also a conventional electrolyzer in which the bio oil mixed with a solution, which I will talk about with an alkaline solution. The bio oil works as a source of carbon for its oxidation and generation of carbon monoxide. If the bio oil is oxidized to carbon monoxide, the only gases coming out of the electrolyzer will be carbon monoxide and hydrogen, and this syngas can be fed directly to the methanation process here. So the idea is, if we can have this syngas production on the electrolyzer, that can be fed to the catalytic methanation of the process. So we are working on different approaches inside this this project. As the electrolyte, what we are using is the bio oil that came from the previous project, that energreen, and CO2 also from the industrial source. The CO2 incorporation, we were expecting to be much more integrated in the bio oil, but so far we're not seeing very interesting results on the CO2. We are having a lot of difficulties on the CO2 reduction. As you know, CO2 reduction is often reduced on copper cathodes. We are using those electrodes in our system, but we're not being able to have the direct reduction of the CO2 on this medium. Also, one very important thing, and by comparison with the previous project which I showed you, the black liquor, which is an aqueous solution with very high ionic conductivity, the bio oil, it's an organic medium. It has very low ionic conductivity. So our first approach was to increase the ionic conductivity of the bio oil. So we have used several approaches for that. So just to show you here the different approaches that we were using inside of this project, the different materials that we tested. We studied the effect of temperature, effects of the oil composition. We studied different effects, but as I was saying, the major thing was to increase the ionic conductivity. We see that the industrial bio oil has a conductivity of only 0.75 millisiemens per square centimeter. So when we started doing electrolysis on that, currents were very low. We tried different approaches, different electrolyte additions, and we found, after several trials and errors, that the one that was giving better results was by preparing an emulsion with an alkaline solution. So 2 molar KOH solutions have very high ionic conductivity, and by preparing an emulsion of KOH with a bio oil, we managed to prepare an emulsion with a conductivity of 190 millisiemens per square centimeter. This is a very stable emulsion that stays for a lot of time after preparation, and we were able to do electrochemistry approaches on this after preparing the emulsion. So you see here, after the mix with the KOH, the bio oil gets this color, looks a solution, and we are able to do electrolysis. So this is just to show you the kind of approaches we did, some studies with rotating disc electrode. Here several scans at different scan rates. I will not go into details because we don't have the time. This is just to show you the different approaches that we tried with NaOH, KOH, lithium hydroxide, lithium bromide, several electrolytes that we tried, and the one that gave the most interesting results was with the KOH solution. We also tried not just different electrolytes, but different ratios, like of the mixture of bio oil and the electrolyte, and the one that gave the better results was this one with 50-50. So 50% of the bio oil, 50% of the KOH solution. So just to summarize the main results that have been being produced on this project, that is still ongoing. We are close to the end of this project, but not yet. But so far, to show the main approach that we've done was to increase the ionic conductivity, which was the main difficulty of this, not just low conductivity, but also high viscosity of the bio oil, and we've managed to overcome that with this KOH solution. And on the tests we've done, we have reached that the ideal conditions for the electrolysis was an applied voltage of around 2.4 volts. Both 2.1 and 2.4 were appealing, but 2.4, of course, gives much better currents. The only problem is we have to make sure that we do not exceed the stability of the material. If you go to too high over potentials, we might have degradation of the electrode material. So far, they are being stable on that. And since the ionic conductivity was increased to reasonable values, we were able to use this bio oil alkaline emulsion in the electrocracking reactor. Only compound that we were detecting, only gaseous compound so far, was hydrogen on this electrocracking. So we are able to cut the organic compounds, to the organic molecules, into smaller pieces, but they're all in liquid state. There is no formation of gas. Only hydrogen is being produced also on this bio oil electrolyzer. So without further delays, I will talk about the third project, because it's the last one, and then I will talk about a little bit on the fourth. I think I still have some time. So this project on swine wastewater electrolysis was related with a PhD student work that was doing work in the company on these pig farms, and also trying to propose a solution for the swine wastewater by doing these studies in our research group. So the idea was to implement electrochemical treatment of the swine wastewater at industrial level. The effluent management in swine farms has significant environmental challenges due to the high volumes of wastewater which are generated with high pollution load. Normally, there are several biological methods that are being applied for the environmental remediation of the swine effluents, but there are practical limitations, and novel solutions are required for the treatment of these wastewaters. Sorry. These electrochemical technologies have unique characteristics that are able to complement the conventional treatments based on biological methods. So the idea is not just to be solely an electrochemical approach, but as a complementary approach to the biological methods. Normally, there are biodigesters on these industries, and we want to couple these technologies. So there are several parts in pig farms. The parts related with gestating, farrowing, weaners, fattening. So the wastes from different parts of the pig farm have different properties. This is also a difficulty, and the student has this is work with Gonçalo Lourinho that I showed in the beginning, and he saw that there were different properties for different parts of the process. Related with the treatment of the effluent, the idea here is to have the oxidation of the pollutants. On this project, we're not trying to recover anything from any valuable compound. We're just trying to oxidize the organic load and reduce the COD on these compounds. On the other side, we are trying to produce hydrogen at the cathode side for energy recovery. So in all these three projects I showed you, the cathodic approach is always the same. Have hydrogen production, hydrogen that can be then fed to like, for example, to a fuel cell which is installed, for example, in a forklift in the factory, and that forklift can be powered by hydrogen. That can be used directly in the factory for electricity generation to increase, for example, the temperature of the ovens on cement companies. The hydrogen is being fed directly to the oven. And that's why I didn't mention that detail, but on the hydrogen production on the project with Cecil, the cement company, the hydrogen that is produced can be fed directly to the oven. And the advantage of burning hydrogen is that it increases the temperature inside the oven. And when temperature increases inside the oven, we are able to have much more efficient combustion of the gases, and then have much more by having much more efficient combustion. Of course, that improves and decreases the amount of fuel that you are using. So having an efficient combustion is also something that can be achieved just by adding hydrogen inside the oven. So a lot of applications can be done on these produced hydrogen. What was the approach that we followed here? Again, we saw that the swine wastewater had relatively good behavior, electrochemical behavior. We can see here the RW and DW goes for raw wastewater and digested wastewater. We saw that we could have the hydrogen evolution reaction in both of them. And on the anodic side, there were some oxidation peaks here occurring. What we did was to compare by adding a small amount also of KOH. Like we were doing in previous project, we also added KOH to increase the ionic conductivity of this solution and get better results on the electrolysis of this swine wastewater. What we see is when we are studying the raw wastewater with the KOH, we have an oxidation peak here, and this oxidation is the anodic process. There is no oxygen evolution reaction. When we just have KOH with no wastewater, we have the oxygen evolution reaction occurring here. Okay, this is the oxygen evolution reaction. But when we add the raw wastewater, no oxygen evolution reaction, so we are able to oxidize the raw wastewater. So I will move because I'm getting short on time. This is just to show you the approach that we've done both for the raw wastewater. Raw means like the wastewater as obtained from the swine, the pig farm, and this digested wastewater comes after the biodigester. So we have to decide if we will do the electrochemical approach on the raw wastewater or after the digester. So the idea was to test on both. Here, this is cyclic voltammograms in both wastewaters at different scan rates. We saw it was an irreversible process because there was a change of the anodic potential with the increase of the scan rate. And we see here a linear relation on these properties. We also did characterization using using FTIR, using thermogravimetric analysis to characterize the products of the wastewaters. And then we went for this lab scale electrolyzer, testing both nickel and graphite electrodes. With nickel anode, we saw that it was involved also some electrocoagulation mechanism on the oxidation of the wastewater. And with the graphite electrodes, it was a different mechanism that was related with the COD oxidation, but was related with the adsorption of fluoride ions on the active site, and then would lead to the generation of active fluorine species that acted as an effective oxidant. So depending on the electrode material, we have completely different mechanisms for this pollution degradation. So just to summarize this work here, what the main focus was on the characterization of the samples, because this was quite unknown. There was not available information on that, and then with this electrochemical oxidation tests, as I mentioned, with these nickel anodes, we did both for the raw and digested wastewater. We had CO2 removal up to 12% with the electrolysis with nickel anodes, but with graphite anodes, the CO2 removal due to this formation of chloride species that I mentioned, these active chloride species, we were able to have CO2 removals between 26 and 30%. So the results were very promising, and it shows the potential of using these swine wastewaters as electrolyte solutions, supporting the perspective that electrochemical-based processes can be integrated in swine wastewater treatment at an industrial scale. So this work of the student was finished. Unfortunately, there was a problem with the company because he was working with the company. The company was very interested, but during his PhD, the company finished, the company bankrupted. So the results were still published in the scope of his PhD, but they were not directly applied, and that it's something that it's a bit sad that they were not used. But of course, as long as they are published, I think other companies can make use of the advances that he managed to reach, and that I hope that we can contribute to that, to improvement of other same swine or pig farms. So just to finish, I want to show you a little bit one of other approach that we're following. Like we had a boom on hydrogen production on Portugal by the last year. There was a lot of funding from the government, like the policy completely changed towards the green hydrogen production, and several companies approached us to ask to participate in projects with them, and we are collaborating currently with some companies which we have submitted projects. We are waiting for the results of the funding of those projects. So I will briefly talk about this electrolysis of water electrolysis. So as you know, the main types of water electrolysis are the alkaline electrolyzers and the PEM electrolyzers. This solid oxide cell electrolysis is something that is still under research. It is very promising, but it works at high temperature. It's still not commercial, but these two are commercial. This alkaline electrolysis is the most mature technology. It is here for over 60 years. And we are working with the company on improving the capacities or improving the performance of electrodes for these electrolyzers. So our approach in the research group has been to decrease the cost of alkaline water electrolysis, either by decreasing the catalyst cost, by moving for low-cost electrocatalysts, or by increasing the electrocatalytic performance. We're having like these two different approaches. Like one of the approaches that we are doing in our studies is, for example, on anchoring metal nanoparticles onto a support. Of course, that increases the conductivity of the catalyst, increases the surface area, the stability, decreases the metal amount and the cost. Other approaches related with alloying transition metals with noble metals. Of course, if we alloy with transition metals, we reduce the cost because we reduce the noble metal amount and we increase the stability of the materials. And for these projects lately, we are working on this third approach that we have also done research in our group, and it's the one currently more appealing for the industry, which is the preparation of 3D metallic foams. These foams have very high surface area and they have very low metal amount because of that they have very low cost. What we do, we produce these 3D nanostructured foams, and since they are so porous, they have very large surface area with a small amount of material because the porosity is very high, so we are able to use only small amounts of material. We are developing these electrodes. It's a bigger project, but our contribution is basically on the development of both anode and cathodes according to this technique, then for incorporation in these alkaline water electrolyzers. So the project has been submitted, but we are already working on that, and the company has said that this is with ISPT. Even if the project is not funded, they will still move because they are really interested on starting on this field, because they know that it will be something important in the very near future. Just to finish very quickly, I want to tell you that I'm also involved on this cost action on waste biorefinery technologies for accelerating sustainable energy processes. This cost action has 4 working groups on raw materials, biorefinery conversion technologies, biorefinery applications. And on this working group on biorefinery conversion technologies, we are also very interested on using electrochemical technologies for the treatment of these waste biorefineries. So we are in collaboration with some groups to have work. This is very good because this is a large consortium. It involves 28 countries and anyone can apply. I'm taking the opportunity to spread here the message because I'm leading working group 4 on communication and dissemination, and we have just started this wire cost action on the social media. We created the LinkedIn and Facebook accounts. So if you are interested on these waste biorefinery technologies approaches, you can follow us on LinkedIn or Facebook. Just look for wire cost action and you can follow what we are doing. Anyone can apply to these cost actions. And this is a very good way to start new collaborations and have very interesting results from this. So I just want to thank the projects that funded these projects that I show you, both Impactus with the Navigator company, this Clean4G with Cecil company, and also to thank you very much for all your attention. I'm open now for questions.
Dr. Diego, for your interesting session. And now I will request participants, if you have any query on this session, you can write in chat box. So many questions and doubts are there in my mind also. but due to lack of time, I don't want to extend this session. Actually, the next presenters are waiting over there to present. So we can plan a separate session with you on your work in near future. Because I have many doubts and
Okay.
questions in my mind. Okay.
You also have my email in the presentation.
Yeah,
so
yeah,
if
yeah.
you want to contact me for Diogo
Yeah.
Santos at Technique Lisboa, you can also send me your question and I'll be pleased to answer you.
Yeah.
Thank you very much.
Okay. Thank you. Thank you. And now we will move to the next technical session. And I think there are total 8 participants are there. And we will start with Mr. Kaushal Kumar Singh. I think he's there. Kaushal Kumar Singh. You can share your
Singh. Yes, ma'am. I'm here.
So you just start sharing your PPT.
Okay, ma'am. Just a second.
Please try to concise your presentation as we are
just
moving lack of time duration.
Mr. Vikram Anand.
Yes, no problem.
Okay. Just a minute, ma'am.
Okay, good. Kaushal?
Yes, Mr. Kaushal. Yes, ma'am.
Are you having some
Sir, please.
trouble to share your screen?
Ma'am, network issue हो रहा है मैम इसी थोड़ा problem.
Okay, so in that case, I have
yes.
presentation. Your presentation is with me. In that case, whether I'll share that one.
Yes, I'm sure.
Okay. Can you see the slides now, Mr. Kaushal?
Yes, ma'am. Yes.
Okay.
Please start with your presentation. Good evening, all of you, ma'am. My name is Kumar Singh from Galgoti University. I am pursuing BTech in Mechanical Engineering. My topic is submerging in flocking, target searching capability in SWAM drawings. And my introduction. So basically, in our topic, we have analyzed the in different parameter to enhance the SWAM drawings in capacity. Yes, ma'am. I am audible.
Yes, you were audible.
मैम जो हमारा इसमें टॉपिक है मैम इसमें हमने एक नेट लोगों का सॉफ्टवेयर यूज करके हम एनालिस किया है जो हमारे स्वयं ड्रोन से मैम उनकी कैपेसिटी को इनहेंस किया है मैम हमने डिफरेंट पैरामीटर पे मैम
Shall I move to
Yes,
the
sir.
next?
Move forward. Yes.
Join in time.
This is literature review जिसमें हमने यूज किया है मैम डिजिटल और मैम काफी इनको हम सॉफ्टवेयर यूज करके मैम स्टमर्जिक कोऑर्डिनेशन बिटवीन स्वयं ड्रॉइंग्स हमने प्रेजेंट किया है उनका मैम जो ड्रॉइंग्स है ऑटोमेटिक कंट्रोल रहता है उनका मैम उस पर जो कोई भी वर्क होता है मैम
Sir, will you move to your result and conclusion part where you have find out your result and all those things and the methodology?
I think you just discuss the basic work, what you have done.
I have basic work done, ma'am. आई एम से अगेन जो हमने मेंस का काम यही है कि जो हमारा एक सॉफ्टवेयर के थ्रू इसे एनालाइज करके जो हमारे ड्रोन्स हैं मैम उन्हें उनकी कैपेसिटी को एनहेंस किया है और डिफरेंट पैरामीटर पर मैम.
So in that case, you would just explain the conclusion part. Okay.
In this article, we are trying to use flocking and emerging behavior to improve the target search operation in SWAM. The drone's emerging behavior to attract drones toward likely target. मैम आधा पार्ट मैम इससे हम दिख नहीं रहा मैम थोड़ा स्लाइड वगैरह मैम रीड करने में दिक्कत हो रही है मैम. हेलो
कौशल.
यस मैम थोड़ा ये आ रहा है थोड़ा रीड करने में कंक्लूजन को दिक्कत होगी मैम डिस्क्राइब करने में थोड़ा
Mr. Kaushal, I think हम लोग फिर in that case we can conclude work your presentation because in that case there is some language issue also because Dr. Diogo is there and we will not understand your language, of course, right?
Yes, ma'am.
Okay. Okay, thank you.
Yes, thank you, Mr. Kaushal. Ma'am, should we move to next participant, next presenter?
Yeah. Yes. So next one is Mr. Vikram Anand.
Vikram Anand.
Yeah.
Yeah, just start my PPT.
Your voice is cracking, sir.
Your voice is.
Is it visible?
Yeah.
Yes, sir. Please put it to the slide mode. Yes, yes, this is visible, sir. Yes, sir. Please continue.
Your slides are visible and you
yes,
are.
I made a PDF.
Okay, no issue. You can start your presentation.
So my topic for the paper is the comparison of ideal binary mask and linear dynamic models for application of a speech. So I'm the Vikram Mane from Shivaji University research scholar from Maharashtra. So these are the contents of my presentation. So I'm going to explain the introduction, something related with the choice of the subject, and then which are the different noises that get affected on the speech. And I have done basically the findings in the area of comparison between the two processes which are widely used for enhancing the speeches. So more I will focus on the what actually the result I have obtained and what is the background of this particular project. As far as the speech is considered, it is a primary form of communication between the human beings. So everybody can convey their thoughts, emotions, opinions, information with the speech as a means. So this vocal communication is going to be a biggest thing in the future as far as the applications of the artificial intelligence or the machine learning is considered. So concerned with this, various things can be brought into picture when you are dealing with the artificial intelligence, that we can go for the vision sense, touch sense, audio sense, smell, and the taste. Among this, I have carried out one of the sense, that is a auditory sense analysis into the machines, and I wanted to see how those computers will act for the various understanding of the speeches. That is actually the thing. So as far as the human being is considered, three things are there in the human auditory system. One is a perception, second is the reasoning, and third is action. So perception stands for receiving the signals from the various sources, and based on this, our brain is doing some process over this, and finally we have the action over the what we have received. So generally what we receive through our ears is the mixture of the sounds, and it is the ability of the human being that to extract the sound of interest from the mixture of the sound sources. So that is actually I wanted to work in this research, and a small model I'm presenting here where I have done the targeting the required speech from the mixture of the multiple sources. So this is recognizing the speeches. Such a problem is called as a crowd noise, and it is popularly known as the cocktail party problem. It was suggested in the around 1950. So it becomes a difficult task for the researchers to understand how the human ears can work, or how human auditory system can work of extracting the targeted signal from the mixed signal. So this, if we are successful in this, this will be a proof for the so many applications like telecommunication, artificial intelligence, audio, and speech signal processing, even for the medical signal processing. So we have just started this, like taking one clean speech, insert the noise in that, and take a mixed noisy speech, apply the algorithms over this, and find out which algorithm will work better for this computational auditory sense analysis systems. So these are the various noises what we have taken for the consideration, like a babble noise, car noise, helicopter noise, the natural noise, kid cheering noise, transportation noise, and finally the random noise that we have taken for the experimental. So this kind of conceptual diagram we am presenting here, but everything is developed in the software, and then we are going to put the same computers in the machine like a robot, so that it will perform the same things, because it becomes a very complex calculations for the microcontrollers. So we are directly using the computer as the processor for the inside the robots, so that they can work like this. So similar to the ideal binary mask, one more algorithm is there, which is called as a linear dynamic model, which is the prediction algorithm, which is also useful for the speech enhancement. So both the algorithms are having their own properties, and we have experiment over these two algorithms, and found certain results, certain findings, and that findings we have presented into this paper. So I will explain certain findings here, that when I'm processing over this particular signals by using the random noise. So in the paper I explained each and every noise, but for presentation purpose I have taken the one noise, that is a random noise. A random noise is artificially inserted into the original sound, and what a mixture of the sound is there, that mixture is given to the ideal binary mask algorithm, and I found that this ideal binary mask is able to target the dominant speech into that particular signal. And when I am comparing with the originality, the clean speech of the signal from the database, I have found the correlation between that signal and the recovered signal. The maximum correlation I found in the IBM, ideal binary masks. So similar kind of the same speech I applied to the linear dynamic model. Actually, it is not a filter, but the signals. So this particular algorithm is a dynamic algorithm, and that is IBM is a static algorithm. So this LDM is also doing the same thing. And
Mr. Vikram, please conclude your presentation within next 2 minutes.
Yeah, no problem. Then we are getting a correlation coefficient as shown here. So I have tabulated the result in this form. So I worked on the various speakers. What with the paper I presented the two speakers, with speaker 1 and speaker 2, which are working over the while inserting the noises like a random noise and the babble noise in this case. So the comparative results are with respect to the correlation coefficient of that reconstructed signal with the original clean speeches is presented here. So what I have found is that as comparative results are discussed above, the ideal binary mask is well dealing with the noise and can be effective method for the robust speaker recognition. An ideal binary mask algorithms plays a vital role in speech applications for enhancing the quality of the speech also. The variation of the correlation coefficient varies because of the working nature of both the algorithms. The linear dynamic models provides a comparatively less effective result in the reconstruction of the signals, especially the speech signals. As far as the prediction mechanism is considered, linear dynamic models are giving the comparatively better results where exact targeted speech is unknown. So both the methods, if you use in a cascaded form, that will be the advantages for so many speech operating systems working over the computational auditory sense analysis. So this is my conclusion, and these are certain references I have referred, and this is my final thing. Thank you. Am I audible?
Rita, ma'am. Yes. Yes, you are audible.
Dr. Dio, if you have any doubts regarding the last presentation, or if you have any question, you can ask. I think there is one question in the chat box. That is, how did you measure the robustness of Kalman filter algorithm for noise reduction?
Robustness has been seen through the experiments only. I have not measured it, but the cross correlation between the observed extracted signal and the original clean signal we have compared, and it has been found that even if some quantities of the signal is unknown to you, the Kalman filter is automatically estimating the in-between values and giving some better results.
Do you have any question?
Can I make a quick question?
Yeah.
I just wanted to ask you if there are plans for any commercial application of these, if you are already, if this is being done in the scope of a project, and if there are companies that that want to implement what you're developing.
Yes, because I am thinking over the how I can improve the hearing machines, so that in the hearing machine the amplification is used, but as per the human auditory system is considered, then if you give the attention to any speaker, then that speaker will be picked up by the brain. So that kind of technique we want to implement. So if it is be successful, then that will be the beneficial for the hearing instruments.
Okay, thank you, Dr. Vikram.
Okay, sir, thank
you. And so in that case, we can move to the next presenter, that is Mr.
Yes.
Akshay.
Mr. Akshay.
Yes, sir.
Yes, please be ready with your presentation.
Sir, please may I know whether it is visible?
Yes, everything is visible. You are audible. Please continue, sir.
Okay. Good evening, everyone. My topic for the presentation is fiber reinforced polymer retrofit scheme for structural members which are subjected to adverse environmental exposures. It is a review paper basically. So the content of the paper are introduction, properties and application of FRP, literature review, conclusion, and a brief future scope. So retrofitting is nothing but basically a technique to adopt and increase the service life of any structure which involves repair, renovation, and part construction. Several buildings may need retrofitting, which could be having design flaws, which are damaged due to disasters, which are historical and memorial buildings, etc. So conventional methods of retrofitting for structural retrofit is sectional enlarging method, pre-stress retrofit, encasement with steel plates and attaching steel plates. Now these were the conventional. Recently there is a new technology which is used widely, that is FRP for retrofitting. So wherein the FRP sheets are glued to the structural member and its strength is enhanced. So FRP is nothing but a composite of matrix polymer resin and high strength fibers, which can be carbon, aramid, glass, anything. The advantages of FRP retrofit are, those are thin laminates, these are lightweight with high strength to weight ratio, non-corrosive, quick installation, economical, etc. Now FRP is used in retrofitting of members like columns, beam slabs, beam column joints. So in columns, these are wrapped around the column for giving the axial strength enhancement. In beams, it can be wrapped around for flexure as well as shear strength enhancement.
For slabs, again, flexural strength enhancement is given by attaching it to the soffit of the slab, and it is wrapped around the column, beam column joints to give the shear as well as flexural strength enhancement at the joint itself. Now, what I have done is I have studied this literature wherein these type of specimens were subjected to say temperature variations for 18 months and so, wherein fracture energy degradation was found. When subjected to moisture, shear strength shear bond strength and tensile bond strength was found to be reduced. When subjected to hydrothermal conditions, the load capacity was seen to be reduced by around 28%. When subjected to freeze-thaw cycle, the debonding capacity was reduced about 30%. Then subjected to fire, when the system was subjected to fire hazard, the flexure strength reduced around 60%. When specimens were preheated, the maximum load was seen to be increased in the FRP system, CFRP specifically, that is carbon reinforced polymer. Then again, surface treatment, bond length, aggressive environment, and glass transition temperature. When these parameters were considered, the most effect of the design strength was found glass transition temperature of the polymer resin. Then grade of concrete, environmental surrounding and thawing when subjected was subjected, the bond strength, stiffness as well as interfacial debonding energy reduced drastically up to 50%. Then again, when structures were retrofitted in marine environment along with ultraviolet rays, the bond strength also increased due to greater polymer cross-linking. Likewise, in marine structure, again, bond length was seen to be reduced. Hydrothermal interface debonding was seen, and for fire protection system, up to 5 hours or more fire ratings was observed using carbon fiber reinforced polymer. For glass fiber reinforced polymer, when subjected to alkaline solutions, ultimate bond load was seen to be higher on externally bonded on groove scheme as compared to externally bonded scheme. When submerged for full and bottom, only bottom of submergence, the fracture toughness was seen to be drastically high in half submergence as compared to full submergence. Then dampness and degree of heat was considered. The load capacity is seen to be reduced by almost 30%. Similarly, for degree of heat, bending properties were checked, and it was found that the bending properties were reduced. For externally aging, atmospheric aging and thermal thing, the failure and stiffness value was reduced. Then again, for temperature, it was seen that properties are reduced. Similarly, for GFRP as well as CFRP, it was seen that tensile strength was reduced to 8 to 10%. For hydrothermal, or up to 40% tensile strength and tensile modulus was seen to be reduced. Then bond performance at high temperature was also seen to be reduced. At elevated temperature, design strength of when fiber orientation was considered, like the unidirectional laminate give much good performance as compared to chopped and woven FRP. When subjected to dampness and degree of heat along with UV radiation, the flexure, tension, and compression strengths were reduced in 34, 28, and 23% respectively. So based on this, I have drawn the conclusions that for durability assessment, the various environmental factors considered were temperature, hydrothermal conditioning, moisture, freeze-thaw cycle, then chemical environment, that is acidic as well as alkaline immersion, ultraviolet radiation, and fire. It was observed that preheating of concrete is favorable due to good bonding and increasing interface strength. When such scheme is exposed to moisture, it is seen that the penetration and absorption is more and having deteriorating effects, but it is more severe in glass fiber reinforced polymer than compared to carbon fiber reinforced polymer. At elevated temperature, both the CFRP and GFRP showed reduction in strength and tensile modulus. In freezing and thawing, GFRP seemed to be less affected as compared to CFRP. When subjected to alkaline and salt water, the GFRP seemed to be more susceptible than CFRP. So likewise, and again for fire, glass transition temperature was seen to be the main factor, wherein near surface mounted scheme performed better than externally bonded scheme. So I have studied all the literature just to find out what are the effects of different types of environmental condition for the said retrofitting scheme using glass fiber reinforced polymer as well as carbon fiber reinforced polymer. Now, based on this, my future scope is to develop a standardized procedure considering all these factors and giving the design, calculating the design strength in accordance with the Indian standard. Because right now we do not have an Indian standard which gives us directly the flexure strength of beam, design flexure strength of beam or axial strength of the column when retrofitted with CFRP or GFRP itself. So this is my future scope of the studies. So thank you. That is all from my side.
Thank you, Mr. Akshay. And I'll request Dr. Diogo if you have any query on this work.
No, maybe I would like to understand now how, after reviewing the literature, how do you plan now to implement the conclusions that you've reached? Because I saw that your work was basically on reviewing what other authors have done, but how do you plan now to go for the next step?
Sir, what I have done is I have reviewed the literature. Based on that, I have found what are the types of specimens that have been used earlier in the studies, what are the types of strengthening schemes that have been used, and what is the type of extreme environmental exposure that they have been given. Based on that, they have calculated either flexure strength, axial strength, or interface debonding strength. So what I'm going to do is I'm going to cast, particularly I'm going for the flexural strength of beams, wherein I'll be using these parameters. I'll be casting beams for myself and then getting the result, getting the flexural strength from the experimentation. I'll be developing a model wherein I can correlate the flexural strength, design strength that I have got from the experimentation along with the previous researchers' work, that if they have got say for the same exposure, if they have got 20% reduction in strength, what reduction I am getting, so what type of specimen they have used, so if there is any differentiation in the size of the specimen, so accordingly I'll be chalking out the standardized procedure to arrive at a design strength that will reasonably give the amount of design strength, flexural design strength for a given beam. So that is what I am planning to do in the further course.
Okay, thank you. Thank you for your answer.
In that case, we can move to the next presentation, and I think the Mr. Sachin Sirohi, he has not joined yet. So in that
Sachin
case,
Sirohi, are you here still? Sachin Sirohi? No, ma'am, please move to the next participant.
okay. In the next participant is Himanshu Pachari.
Yes, ma'am.
Yeah, you can start
Yes.
your presentation.
Okay.
Mr. Himanshu, please try to conclude your presentation within 8 minutes. Okay.
Okay, sir. Okay. Is it visible?
Yes, sir. Please continue.
Okay. Good evening to all. I am Himanshu Pachori. This is actually a short review of the significance of thermal storage material in solar air heater. So the list of contents are introduction, classification, and the differentiate between sensible and thermal storage material, and then assessment of the energy storage material. So now the introduction, actually we know about the solar energy. Among all the solar energy, renewable energy, solar thermal, solar energy is an intensive energy producer all over the world. Actually, a solar irradiance impact on the surface is estimated around 5,000 trillion kilowatt per year. So in this review shows that the significance of thermal storage technique for the sensible and related heat storage applied in a single and double pass solar air heater, which also emphasize of the heat transfer in solar thermal storage system. The performance and differentiate between the single pass and double pass with packed bed solar air heater are also examined, and I mentioned the recent advancement and improvement of the transmission of solar storage system. So in this, when we talking about the classification, the thermal energy storage system basically classified as a chemical storage system and thermal storage system. So I'm basically focused about in this paper the thermal storage system, which is also classified as a sensible heat storage system and latent heat storage system. So in this latent heat storage system, the phase change material we can use in this storage system, because phase change material, the transformation of the solidification to gasification or in a liquefaction progress, we can get the better efficiency as compared to thermal storage system, because the sensible storage system, there is no phase change material, and the time we need extend the time of thermal storage system in latent heat because of the phase change material. So this latent heat also classified as a organic, eutectic, and inorganic. And when we're talking about the organic, because recently research focused on the organic material, the paraffin compound, paraffin wax, recently used for thermal storage system. When we're talking about the solar air heater, when the sun fall on the absorber plate, so it store the energy, and this store energy we can not use continuous after the sunset. So we need this storage system, sensible or latent based storage system, which can absorb the uh, energy, and we can use even after the sunset, because this solar heater basically used in industrial, agriculture, for as a dryer, and different kind of application as a room heating application, etc. So when we talking about the single pass solar reactor with thermal storage system in a sensible, so we can this range goes up to the 100 degrees Celsius, and it is a simple in manufacturing. But when we convert single to double pass, so this can increase the performance of the system, because of increase the surface area of the thermal collector, and that's why it can give the better performance that than a single pass solar heater. So in a sensible solar heater, we can the heat transfer rate we can conclude that as a MCP, the final temperature to the inlet temperature. When the solar heater with latent thermal storage based, so in a single pass we can directly put encapsulated phase change material inside the tubes, and the flow of air from inlet to outlet as shown in the first figure. So the paraffin wax store the thermal energy. Same thing when we compare with the double pass, so we can use at the encapsulated capsule in the bit below the absorber plate. We can see the absorber plate in second figure, double pass solar air heater. Inlet air goes above the absorber plate and then revert to, and goes to the down from, and go to the outlet chamber. We can apply it in different field. So after that, over the period of uh, sun rises, so the phase change material and which is encapsulated in the tubes store the energy, and they give the energy even after the sunset. So we can easily and useful for after the sunset. When we're talking about the equation of the, there is a major difference. The heat diffusion rate is play a better role, because of the during the phase change, so diffuse the energy during the phase change. So it can give the better efficiency than the sensible heat storage. When we talking about the thermal performance enhancement technique, in
conclude your presentation, Mr.
Yes,
Himanshu.
sir.
Please conclude.
Okay. In latent thermal energy storage system, so we can apply it as a we can extend the surface. As shown in figure, we can use the longitudinal fin, pin fin, and spiral fin, which can increase the heat transfer rate. And when we when air flow over on it, so increase also turbulency. With turbulency, increase the heat transfer rate. So alternate fin shape which employed to improve the heat transmission interface of a storage surface. We can use as a nanoparticle such as the aluminum oxide in the PCM material to increase the conductivity of the PCM material. When we compare to the sensible heat storage, latent heat, and combined. So combined combination of sensible latent heat storage that give the better efficiency because of the we can utilize the both application sensible and latent. So when the conclusion part is that latent based heat storage gives the better performance than the sensible is. And when the researcher also focused on the combined performance of the sensible and latent heat storage, which is also give the better performance. Okay, sir. These are references. Thank you, sir.
Request Dr. Diogo if you have any query on his work.
Yeah, I just have the question. I was looking at the conclusions, but I didn't have time to read everything. Just, but in your opinion, for a practical application of the system, do you suggest to be more based on sensible heat or on latent heat? Which one is the one that you think that that can have faster application of what you're suggesting, of the technology you're suggesting?
Yes, sir. When we're talking about the application point of view, the latent based give the better performance, and it will also use. It is using in agriculture in India. It is frequently using as a dryer. When we're talking about the to dry the vegetables, and we're talking about the leather industry. So this type of dryer we can use. We can use application of as a dryer. So it is when because the conventional dryer take a lot of electricity, as we know, and intermittent of the electricity, so we can replace as a solar system as a with a phase change material which give the energy even after the sunset. So it is good solar thermal technology. Sir, thank you, sir.
Okay, thank you. Very interesting call. Thank you.
Thank you, sir.
Dr. Diego, and thank you, Mr. Himanshu.
Yes.
Now, I will request Mr. Sachin Sirohi, as he has joined, to share your presentation. Mr. Sachin?
Yeah, ma'am, I'm sharing.
Yeah.
Yes, please share.
Can you make me presenter?
Okay. So you are present.
You just share your screen.
You just share a secure, everything will be visible. Yes.
Just put it in slideshow mode.
Put it to the slide mode and
Just wait for a minute. Yeah, my topic is investigation for mechanical properties of dissimilar frictional stir welding joints of AA 5083 and pure copper. So we know that joining of different grades of aluminum alloys is a very difficult task because weld by conventional fusion welding techniques due to high heat transfer and uneven shrinkage and porosity in the welding joints, and there is a unusual growth in it. Again, the above mentioned problems were faced in the welding of aluminum alloys due to the overheat in the process. But as to avoid this, friction stir welding generates low heat during the process of welding, and its heat generation can be controlled easily by various process parameters. Therefore, FSW friction stir welding solves the problem encountered by encountered by the welders in the conventional welding processes. So now, what is FSW? In FSW, generally a rotating tool with well-designed pin is first plunged along the depth of the workpiece and then start to travel along the line of butting. The heat is generated by friction between the surface of the solder, that is the tool, and the workpiece. And as shown in the figure, the tool, this is the tool, FSW tool, and this can be given any shape, and this is tool pin that is used to generate heat. The material is softened by this heat, and the softened material is mixed by the stirring action of the rotating tool pin. Now, advantages of FSW over the conventional machining or conventional welding process. FSW can fabricate the welding joints at a lesser temperature and then the recrystallization temperature of the aluminum, so that there is no melting of material will take place, which prevents the vaporization and recasting of the metals, which cause problem like porosity and heat affected zone. And there no filler material is required in this case of FSW, and the tool is used is a non-consumable tool and one, and which can weld to a very high length. There is no use of shielded gas here, which makes it a more green process. FSW is generally efficient welding process also. So it also removes the constraint of joining two dissimilar metal, even different in properties and melting temperature as well as. So it in conventional machining, there is a lot of constraint of melting temperature materials they usually, and in this case we don't have. So in literature survey, fabrication of dissimilar lap joints of AA1060T2 and copper with different dwell times. The fabricated joints was tested for microstructures, tensile strength, hardness, and the dwell time caused high heat to the material, which affects the depression of the intermetallic compounds in stir zone and leads to an increase in hardness. According to Shankar et al., successful fabrication of friction stir welding joints of similar materials of different thickness of 1050 and copper, that is oxygen free. The maximum joint efficiency was achieved in the study was around 91% of A1050 AA. According to Chen et al., analyzed the quality characteristics of electrically assisted friction stir welding joints of AA and 2219 and observed that the mechanical strength of this joint is higher than the conventional welding joints. When the value of electric current was around 100 ampere to 400 ampere, the strength was 2.74 to 7.38% higher than the conventional one. According to Kundu, presented the effect of friction stir welding process parameter on the generation of heat during the process. The study found that RS is the most significant parameter. Rotating speed is the most significant parameter for all considered response. So these are the parameters. According to tool pin, we can change the pin profile. We can change the pin diameter. We can change the solder profile, solder diameter. In machine,
Mr. Sachin, please conclude yourself in next 2 minutes.
Okay, sir, sure. Thank you. Transfer speed, tilt, plunge depth, and axial forces. So we have experiment setup. We have done this on vertical milling machines. And to join two different materials, we designed special fixtures. And these are the various parameters that is used to make the tools and machine setup. So this is the work material. The present experiment setup is an attempt to fabricate friction stir welding joints, dissimilar metal, aluminum and copper, pure copper. These are the chemical composition of different these two materials. These are the working parameters. We have taken rotational speeds to 800, 1200, 600, 1600 RPM. Transfer speeds, this one. Tilt angle, plunge angle are shown in the PPTs. So next is your tensile specimen. These are the samples that we have prepared. and these are according to ASTM 0.8M standards. These are the tensile test results at various speeds, 1200 RPM and 1600 RPM. And these are the UTS, YTS, and EL percentage evaluation. In case of result, we have received better result yield strength at 1200 RPM. Similarly, the ultimate tensile strength is also higher in rotational speed around 1200, and that is 248.8. And result of elongation at percentage elongation is, again, it is better at 1200 RPM. So we can conclude the RS is found to affect the various variations of tensile strength properties as it is graphically depicted. Adequate heat input is essential for maximization of quality and tensile properties of friction stir welding joints. The UTS, YTS, and EL are maximum at 248.4 megapascal, 158.2, and percentage elongation is 11.9 respectively at 12,000 RPM rotation speed. These are the references. Any query, please?
Thank you, Mr. Sachin. If anybody has any query, they can ask. Okay. Thank you, Mr. Sachin. I think nobody has any query regarding your regard. Dr. Diogo, do you have any question on his presentation?
Yeah, thank
No,
you.
no, for this one, thank you very much for your presentation.
Okay, thank you. Okay. Then we can move to the next one. It is Mr. M. Vijayanand. I think he has joined.
Yes, ma'am. Good evening.
Yes, Mr. Vijayanand.
Yes, good evening, ma'am.
The presentation.
Is my screen shared, ma'am?
Yeah, it is visible.
Yes, yes. Please continue. Good evening to all of you. Myself, Vijay Anand from Anamala University, Department of Manufacturing Engineering. My title of my paper is Modeling and Optimization of Amphoteric Surfactant Concentration in Electroless Nickel Boron Coatings for Maximum Micro Hardness. And these are the list of contents. And the aim of the experiment is to develop an electroless nickel boron coatings by eliminating the heavy metal based stabilizer with the addition of amphoteric surfactant, and also to develop a mathematical model using regression and artificial neural networks in order to relate the concentration of surfactant as an independent variable and micro hardness as a dependent variable to optimize the micro hardness at the critical missile concentration using genetic algorithm. And electroless plating is nothing but it gives a protective metallic or non-metallic coating in the absence of electric current. It is also used widespread application in many metal products finishing industry, chemical and electronic industries, also in medical implants. And what is critical missile concentration? So usually the purpose of surfactant used in the electroless nickel boron coatings is to improve the wettability of the wettability between the substrate and the electrolyte solution. So the proper quantity of proper quantity usage of surfactant is necessary. If we use, so this figures explains if it less than CMC, it will be act as a monomer. When it is equal to critical missile concentration, it will be in the form of layer. When it exceeds the critical missile concentration, it will be formed in missiles. So we have to use a particular gram per liter to avoid the missile formation. The substrate used in this coating is aluminum 7075 alloy of diameter 25 mm with 5 mm thickness. Usually aluminum alloys are highly affinity to oxygen. So that layer has to be removed before the plating. So mechanical polishing has been carried out in order to remove the oxide layer. Also, for any coatings, proper pre-treatment is mandatory. So double zincating with the nickel strike was carried out as per suggested by Dior and et al. And the micro hardness measurement was carried out as per the ASTM E8417. We have carried out a Vickers hardness testing 5 different locations on the samples we have carried out, and the average was reported as a hardness value. And the following parameters were maintained in the electrolyte bath: nickel chloride as a source of nickel, sodium borohydride as a reducing agent, trisodium citrate as a stabilizer, and 3-N, N dimethyl mystryl amino propane sulfonate we have used as an amphotonic surfactant. This surfactant concentration only we have varied from 0 to 0.162 gram per liter. So this we have taken based on the manufacturer data and also as per the literature review. And the other parameters we have kept constant, that is ethylene diamine 90 ml per liter as a complexing agent, and the temperature of the bath was maintained between 84 to 86 using PID controller, and pH was adjusted by using sodium hydroxide as and when required, and it is maintained between 12 plus or minus 1. The coating was carried out without bath agitation for 90 minutes, and the softwares used in this work is Microsoft Excel and the Matrix Laboratory. The Microsoft as well as the Excel as well as the Matrix MATLAB we have used to generate a model equation, and genetic algorithm we have used for optimizing the surfactant concentration. And the experiments were carried out, and the micro hardness values are reported here. And in order to optimize the surfactant concentration, initially for the experimental value using Excel, we have developed an using the Excel in the linear, quadratic, power, exponential, logarithmic equation, the regression models initially developed. So the models were ascertained by means of the R-square value. So among the model, only for the quadratic, we have get a R-square of approximately 98.6. So from here, we have considered the quadratic for the further optimization. And another technique also we have used as a backpropagation neural network algorithm. So in this backpropagation neural network algorithm, TANSIC was used as a transfer function. So this is the VPNN architecture. This input layer we have considered as amphoteric surfactant, and this is the hidden layer which consists of 3 neurons. This 3 neurons also we have selected in this study based on the mean square error. So for the with the 3 neurons only we have achieved a minimum mean square error which is close to 0. So we have used 3 neurons in the hidden layer and the output layer as a micro hardness. That's why we have considered 1, 3, 1 as a architecture. That is 1 represents input, 3 represents the number of neurons in the hidden layer, and 1 represents the output. And from here, so from the BPNN automatically, we will get a experimental value along with the BPNN value. Then here the goodness of the fit for the models were evaluated by using R-square. So here for usually BPNN will consider training, testing, and validation 15, 15, and 70. And the overall R-square we achieved is 99.3%. And the influence of surfactant concentration on micro hardness and surface tension. So this graph represents whenever the surfactant concentration is increased, the surface tension is getting reduced. So it represents the critical missile concentration point. Once if you use the surfactant concentration beyond the critical missile concentration point, there will not be any further improvement, or it will deteriorate the properties of the coatings. So as well as here the micro hardness value, if you see, whenever the surfactant concentration value is increased, so it is approximately between 0.04 to 0.06 only we achieved a maximum micro hardness. Further increasing the concentration of surfactant concentration, which reduce the micro hardness of the deposit. So in order to optimize this, we have used a genetic algorithm. So the models were the model equation what we have achieved in the Excel as well as in the MATLAB, we have used here as a fitness function, and we have achieved a maximum micro hardness of 852.064 at the concentration of 0.064 gram per liter. And the conclusion is the electroless nickel boron coatings were developed on aluminum alloy with eco-friendly trisodium citrate and ethylene diamine as an additives to study the concentration effect, the surfactant concentration on micro hardness of the deposit. A model relating surfactant concentration and micro hardness was developed using regression and BPNN modeling, and the models were Hello.
Yes, sir. Please continue.
Yeah, the models were ascertained by means of the R-square value, and the critical missile concentration is found by using the genetic algorithm for the surfactant concentration of 0.064 gram per liter. We have achieved a hardness of 852 plus or minus 20 hardness value, weaker hardness value. When compared to without surfactant addition, the improvement in the hardness is approximately 44%. Thank you. This is the references.
Thank you, sir. Ma'am, Joyita ma'am.
Thank you, Mr. Vijayanand. And now I'll request Dr. Diogo if you have any query on his work.
Thank you, Dr. Vijana, for your very nice presentation. I just want to ask you, because in some point, it seemed that when you were increasing the surfactant concentration, there was a large decrease of the microRNAs on your initial slides. Why was it decreasing so much?
Sir, actually,
can you explain a bit that on
yes,
how?
sir, yes, sir. The
Because
purpose of
it didn't seem beneficial, because the increase was decreasing a lot the microRNAs.
The purpose of using surfactant in particularly nickel coatings is nothing but in order to improve the wettability between the solid as well as the liquid. The solid is nothing but my substrate, and liquid is nothing but the electrolyte solution. So we have to use the surfactant below the CMC value or exactly at the CMC value. So if you use beyond the CMC value, sometimes what will happen, you will not get any much improvement. It will be stable, or it will deteriorate the property of the coating. So as per the manufacturer data, the CMC of the surfactant lies between 0.12 and 0.4. They have not mentioned exactly. As well as the literature review also, we found that it is between 0.1 to 0.4 millimole. So we want to also the amphoteric surfactant cost is very high. So exactly we want to know the CMC. That's why we have used like this. So if you use beyond CMC, sometimes what will happen, that there will be a stable. There will not be any improvement in the hardness, or it will deteriorate the property, that is hardness of the coatings. If you use below the CMC also, you will not get much improvement.
So when you were showing that decrease of the microRNAs, you were already beyond the CMC value, right? When it was
we have actually verified with the surface tension graph also.
Okay, thank you very much.
Thank you, sir.
Thank you, Mr. Vijayanand. Thank you for your nice presentation and work. And now we will move to the next participant, Mr. Ajay Yadav.
Good evening, ma'am.
Good evening. Please start sharing your presentation. Please put it in
Yes, Mr. Ajay, please
mode.
continue.
Yes, sir. Yes, sir.
In the slideshow mode and continue.
Sir, is it visible, sir?
Yes, yes. This is visible. You are audible. Please continue.
Good evening to all. I, Ajay Yadav, PhD scholar from Department of ECE, NIT Jamshedpur. Topic of my presentation is design and analysis of optical switches using electro-optic effect based Mach-Zehnder interferometer structure. These are the table of the contents. Introduction, Mach-Zehnder interferometer, electro-optic effect, switching phenomena of Mach-Zehnder interferometer, simulation results, and conclusion. Introduction. Optical logic gates are essential element for next generation high-speed communication system. It performs various signal processing and functionality. Example like switching, addressing, multiplexing, demultiplexing, coding, decoding, and number of complex digital implementation are possible. Implementation of logic gate in the optical domain provides the additional advantage of optical communication system, like immunity to electromagnetic interference, compact design, low cost, and low transmission loss, signal security. Mach-Zehnder interferometer. The electro-optic effect-based Mach-Zehnder interferometer structure can be used as a powerful optical switching unit. The appropriate configuration and the of the electro-optic effect Mach-Zehnder interferometer can be result for different optical and combinational sequential digital logic circuits. Now, there are some specific types of material where refractive index can be changed by application of suitable amount of voltage across the material. Using the concept of electro-optic effect, it is possible to construct different integrated optical devices and fiber optical waveguides. The integrated optical devices can be fabricated on a single wafer, and it has ability to change the characteristic of optical signal flowing through the waveguide. The material used for the implementation of optical logic devices is lithium niobate, is an anisotropic material which has refractive index in the different direction. Basically, the change of refractive index profile depends on the amplitude and direction of the applied electric field from the axis of the fiber. Now, equation 1 shows that the change in refractive index due to the application of external electric field, and equation 1.2 shows the phase difference generated due to change in the refractive index, where lambda is the wavelength of signal, n is the refractive index of the material, d separation between the electrodes, r electro-optic coefficient, v voltage applied across the waveguide, and l is the length of the waveguide. Using the concept of the electro-optic effect, it is possible to generate the powerful optical switching devices from the Mach-Zehnder interferometer structure. Figure 1.2 schematic view of the Mach-Zehnder interferometer shows the layout diagram of the Mach-Zehnder structure. The structure consists of input and output directional coupler separated with the straight waveguide. The structure is associated with the appropriate set of the electrodes across the across the length of the waveguide. Now, the optical input is applied to the first input of the Mach-Zehnder interferometer structure. The signal first combines and get splits into two equal ports. The equally divided signal are allowed to travel through the straight waveguide section. In a meanwhile, we require to generate the amount of phase difference across the straight waveguide section. Through the externally applied electrodes voltage, the signal combines and is split among the two output arms. Equation 1.3, 1.4 and equation 1.5 shows the transmission matrix of input directional coupler and straight waveguide and output directional coupler. The detailed mathematical derivation suggests the mathematical expression of normalized output power, which is represented by equation 1.6 and 1.7. Now, the figure 1.2 describes the simulation of Mach-Zehnder interferometer simulation result, variation of control voltage. As the voltage increases from 0 to 6.75, the normalized output power gradually increases from 0 to 1 at the bar port and decreases from 1 to 0 at the cross port. In similar manner, the reverse effect is applicable in the second column. The opti-BPM generated result of layout of MZI shown in this figure 1.4. The proper selection of control voltage provides the suitable result of MZI, where figure 1.4a shows the output at the through port when the control voltage is 6.75, and figure 1.4b shows the output at a drop port when the control voltage x is equal to 0 volt. The electro-optic effect has the various application like the optical modulator, optical intensity modulator, and the directional coupler. Now, conclusion. An approach to the fundamental concept of Mach-Zehnder interferometer is described based on the electro-optic effect and the phase of the signal. The research shed lights on the full discussion on an electro-optic effect-based Mach-Zehnder structure with complete mathematical description with suitable MATLAB simulation result, and the appropriate units are verified using opti-BPM tool. The opti-BPM is further used to analyze and verify the proposed structure. The opti-BPM is the powerful and user-friendly software that enable us to create the different integrated and fiber optic guides wave problem for the on our computer. These are the various references which we have taken during our research, and thank you, sir.
Thank you, Mr. Adar. And now I'll request Dr. Diogo if you have any query on his work.
Thank you, Dr. Ajay, for your nice presentation. I just wanted to make a quick question to understand if you are doing this research in the scope of a project, and if you plan, if there are plans to introduce these developments that you've been working on.
Sir, this is the basic fundamental concept which I have presented of the Mach-Zehnder interferometer structure, and this Mach-Zehnder interferometer can be implemented for various optical logic devices like universal logic gates and combinational and sequential circuits, sir. This can be implemented on this. And I have presented the electro-optic based Mach-Zehnder interferometer structure, and one type of more interferometer structure is there, that semiconductor optical amplifier Mach-Zehnder interferometer, sir.
Okay. Okay, thank you.
Thank you, sir.
Thank you, Mr. Azhar, for your nice presentation.
Thank you, ma'am.
Now the next session is of Dr. Tushar Kantibera. Actually, he was busy delivering his lecture in another room. So he will just join within 30 seconds. Just wait for a few minutes. He will be joining. And his topic is on wireless impedance monitoring of biological tissues using Internet of Things, possibilities and challenges. Tushar, sir, have you joined here?
Hello.
Yes, sir.
Yes.
You are audible.
Okay.
Just
So
start sharing your presentation.
okay. Okay. Thank you. Thank you, ma'am. My screen is visible?
Yes, sir.
Yes.
And you are properly audible. You can start your presentation.
Okay. Thank you very much, ma'am. Good evening, all respected session chairs and all the dignitaries who are present today. So today I will discuss about one review work, which is basically on wireless electrical impedance monitoring of biological tissue using the Internet of Things, the possibilities and challenges. So we will discuss about the bioelectrical impedance, how the impedance comes from our biological tissues. So human body is a complex object developed with cells and tissues. And if we look into the cells are developed with cell membranes, and cell membranes are developed with the protein, lipid, protein bilayers. So if we take any tissue section, and if we apply some electrical signal, and if we measure the voltage, we will be able to get the electrical impedance along with its phase angle. And as the tissue composition are changing with the health status, so definitely health conditions or disease can be detected from the impedance data. And sometimes some food quality also are possible to be detected or assessed with the help of information regarding its electrical property like electrical impedance. So many papers are found from reputed journal conferences where those are published from the reputed research groups who are working in the field of electrical impedance. And there are several dimensions or directions where the electrical impedance can be assessed for detecting the disease or the health conditions, starting from the bioelectrical impedance analysis, electrical impedance plethysmography, or electrical impedance cardiography, which are applying electrical signals at a single or say 2 or 3 multiple number of frequencies. But in case of electrical impedance spectroscopy, the impedance is measured at a number of frequencies, and with the data, impedance data collected at a series of signal frequencies, we will be able to get the Nyquist plot. Nyquist plot is the graphical representation of impedance data, where the real part of the impedance, that is denoted by the R, are plotted over the X, that is the imaginary part of the impedance. And we will see that in most of the cases for the biological tissues, we will see that the Nyquist plots are coming with a part of the circle or semicircle. So we call it as Nyquist plot, and with the help of the circle fitting technique, we can get the impedance parameter. So these are about the electrical impedance analysis. Now, why the impedance data or impedance diagnostics can be converted into the imaging field? Because whenever we will go for any medical imaging technology, we need some spatial distribution of tissue or tissue structures. So it was started with the X-ray. Professor Roentgen was working in his laboratory, and he invented the X-ray. After that, X-ray imaging, X-ray computed tomography, which have been proposed by Alan Cormack and Hounsfield. They got the Nobel Prize for their groundbreaking research. And in case of the tomographic imaging technology, any signal is applied and the measurement is conducted with the signal detectors. In case of X-ray, there will be some X-ray source which is rotating in this animation, and the yellow color boxes will be considered as the detectors which are placed at the circular path or gantry. So this type of imaging is called the computed tomography, and that computed tomography is very, very useful for detecting a lot of diseases, and also it is useful for studying the anatomical structure of the human body or any other subjects. Now, the CT or computed tomography, which is using X-ray, it is not very safe because it is using the ionizing radiation. Also, the amount of the instrument, cost of the instrument is very high, and also the instrument is not portable. It is not possible to be taken to the patient side. Patients are always required to be brought to the clinics where the instrument is installed. So this is a huge instrument. So, and for that, some other applied physics techniques are utilized for developing some portable imaging techniques if it is possible. And with utilizing the science and engineering, we can get several types of alternative medical imaging technology. But in most of the cases, the instruments are not found as a portable CT. So for getting the CT in a portable form, we think about the electrical impedance tomography, where the impedance is also measured. But as the tomographic imaging technique can be conducted whenever we will have the scanning of the data collection throughout the 360-degree rotation. So here also we will collect the impedance with the help of the current injector and the voltage measurement device, and we will repeat the measurement techniques so that we can scan or we can look through the maximum possible angles around the 360-degree rotation over the object. So if you consider one circular domain, and if we attach the electrodes, certain number of electrodes, say, for example, here the animation shows 16 electrodes are taken. If we have some current injector, we can inject the electrical current and we can measure the voltage at the boundary electrodes, which are called the sensing electrode, or the red electrodes are called the driving electrodes. Now, if we have some voltage measuring device like voltmeter, and if we send the data to the computer, and if we have the known physics, which is representing the relationship between the conductivity distribution of the tissue and the voltage developed, then we can get, or we can develop the Maxwell's equation. So that Maxwell equation is called the governing equation, which is partial differential equation that can be solved using the optimization technique, and we can get the spatial distribution of the conductivity imaging. So that is called electrical impedance tomography, and the system can be developed in a portable form, which is the prototype what I have developed during my PhD. And around now we are reviewing that work, whether that technology can be possible to be applied in a wireless mode or IoT-based technology, because in many cases where the rural patients are there, it is not possible to provide the instrument to them. So, and also they cannot travel for the long distance to come into the clinic. So as the instrument is portable, so we can send the instrument to them, and they can also put the electrodes, and with the instrumentation attached to the electrodes, also they can send the data to the imaging devices like computers and all. So always the computers or the computation devices are not required to be present at the patient side. So if the sensors and the electrodes and the small instrumentation are there at the patient side, they can take the data and they can send the data to the mobile phone or any other IoT-based technology. So that is the concept that if it is possible, people are working, and we are working on the review of that work. So as we have understood that the technology can be made portable, and now we are thinking that whether this technology can be possible to be attached to the patient's body in one place, and the imaging can be made in other places. So there are several advantages like non-invasive, radiation-free, and low cost. So that technology has been found to be applicable for medical imaging techniques, chemical reaction visualization, that is in chemical engineering, also in the biotechnology for visualizing the cell culture, mine detection techniques in the defense field, and also in the civil engineering for detecting the cracks and voids in the concrete beam. And geotechnical engineer also applying this technology known as the electrical resistance tomography for identifying the minerals or the water content underground, stored in underground. So these are the techniques for data collection, and these are the instrumentation, and that is the visual picture of one instrument developed in our laboratory. Can be applied for chest imaging. It is suitable for the neonate because it is applying only 1 milliampere currents, alternating in nature. So we can apply that technology for the breast cancer imaging. And the Dartmouth College of USA is also working on that. University Sheffield UK is working on the brain imaging. And also in University of Bath and University of Leeds, they are working on the slurry imaging with the certain number of electrodes, 16 number of electrodes. There may be several layers, and we can get 3D imaging also if we increase the layer. So if we apply the or attach to the electrode to a tree, also we can get the cross-sectional visualization of the tree as that this is a real picture of the tree, and we can get the impedance profile at this domain. So this type of technology is well established now, and a few instruments are also have been developed as a commercial instruments. The left side instrument is developed with the collaboration of the Sheffield University and Maltron, and they have named as the Maltron MK3.5. This is for pulmonary imaging or chest imaging. This instrument from Russia, and that is developed for the breast imaging. And the rightmost instrument is developed from the Drager Medical Germany, and that is also for pulmonary testing. And its instrument name is Pulmovista 500. So many startup companies are working, and many researchers are working in the university and the research centers. And here we are just studying the possibilities for the IoT-based EIT technology. So we have gone through the technology that how the IoT can be applicable for transferring the analog data after conversion it to the digital data, and from the other side we can take the data and we can. So those things are very basics, where the parallel data can be converted to the serial one, and serial data will be transmitted to the transmitter, and the receiver will receive the data, and that will be again converted to the parallel data with the say decoder ICs. So this is the very basics form of the wireless transmission of the data, which is required for transmitting the voltage current data of EIT. So these are the examples by which the biomedical instruments in the IoT-based system works. So this is for blood pressure monitoring, and this is for ECG data transfer. So definitely the EIT data, which is also voltage signal data, that can be also possible to be transferred. So few instruments have been developed as a portable instrument, and that was found just as a say mobile phone dimension, means very small hard drive or whatever is looking like just like a mobile phone. And that small instrumentation or miniature instrumentation can be also put in a pocket or vest, and we can get the data and we can send it to the other part where the computational system will be there for getting the data. And doctor can reconstruct the image, and they can visualize the data, and they can diagnose if any abnormalities are there or not in the patient. So that type of technology can be applied for the breast cancer screening also. From the people who are staying away from the clinics also, they can get the data in the mobile phone, and they can send the data to the doctor side or clinic side. So applying the several number of belts also, we can get the three-dimensional picture with the help of image processing technique. That work is also going on. So electrical impedance spectroscopy, which is signal analyzing technique, is also found to be applicable with the help of the IoT for data transfer, and also for biosensing and other point of care monitoring technique for kidney health. That type of wireless technology is also found suitable. And in MIT also they are working
Dr.
on the,
Tushar, please conclude, sir. Please conclude.
Yes, sir. So in MIT also the instrumentation have been developed for studying the EIT imaging, and that is also possible to be transferred for wireless technology. So I have reviewed few papers and I have listed here. So as a conclusion, physiological monitoring is required to study for human health, and wireless physiological monitoring enables us to remove the connecting wires, and flexible measurement possibility is there. So wearable EIT systems have a lot of potential and medical diagnosis. A number of research opportunities are there to explore the nature and behavior of the wearable instrumentation used for medical science, especially in the impedance-based medical imaging technologies. So thank you very much. I acknowledge my institute and the organizing committee of ICMMIT 2022. And I thank all the dignitaries and the session chair for giving me opportunity to present our review work. Thank you very much.
Thank you.
Thank you, Dr. Bera. Thank you for your nice presentation and nice concept also. Now I would like to request Dr. Diogo if you have any question.
Yeah, so I just want to make a short comment. First, to thank Dr. Tushar for her excellent presentation. I was very surprised. Like, of course, there was a lot of content on the presentation for short time, but I was very surprised to see this technology, and I think it's very interesting. And I like to see that it could be applied to human beings and also, for example, for trees to assess the physical condition of the trees. So I think it seems very promising, and I see that you've done considerable developments also in your laboratory. What I wanted to understand is if this is already being applied, if you already are working towards the commercialization of the technology that you're developing, and if this is already being applied or it's still on the research level.
Sir, actually, the commercial instruments which are available, those are costly. So depending on the economy, definitely many people cannot purchase that. So in our country, so we are trying to develop at a low cost level, so that miniaturizing the electronics and also utilizing some modern electronics technology, we can reduce or cut down the price. And we are working towards that direction so that it will be suitable for sending the instruments or making that instrument available for many number of clinics and hospitals, so that the rural people or the people from the interior areas, they are also getting the opportunity to go under the research or go under the diagnosis. So this is our aim, to make it low cost devices.
Okay, so but the devices, you are working towards decreasing the cost, but is it already being applied and you're reducing the cost? Okay.
Okay. Yes. Yeah, before reducing the cost, that system whatever is developed in our laboratory, that has been applied on the patient volunteers. So we have already studied the imaging of the leg and thigh, and we have imaged the femur bone and the tibia fibula of the other body parts. Those bones have been also detected and visualized very nicely.
So you're trying to reduce the cost so that it can be more widely available.
Yes.
More people. Okay, thank you.
Yeah.
Excellent.
Thank you, sir.
very
Thank you very much. Thank you very much.
Dr. Bera. With his presentation, this session ends, of course. And I'd like to thank all the presenters and participants for keeping the patience throughout the session. Our special thanks extends to Dr. Diogo for joining us and spending long time on various sessions. And I'll request you to join our valedictory session on tomorrow. And of course, I'll share a link and timing to join that session. Okay. So I'll request you to join that session. Okay. Thank you. Thank you. And now I'll request Mr. Lalit ji to close the session.
Close the session.
Thank you, ma'am. Thank you, sir.
Yeah. Thank you, Diogo.
Thank you to all of you.
Thank you.
Thank you very much for the presentations and for leading the session. Thank you. Goodbye.
Bye.
And
So shall I end the session? Brijesh sir? Brijesh sir, shall I end the session? Sir, shall I end the session?
Hello.
Sir, shall I end the session? Shall I close the session, sir?
Yes, sir. Please close.